Hello, my name is Brian, and I am here to hack on some Tiger Beetle stuff. Specifically, the project we're working on lately is the Rust client. So, Tiger Beetle, the financial database, has clients for a number of languages that you might want to connect to it with, but it doesn't yet have a client for Rust, and there is some demand for a Rust client and likely to be more in the future. And I am a competent Rust programmer, so that's what I'm working on lately. I'm doing the whole thing on stream, so if you follow this stream for the weeks and months it takes to really polish up this project, you'll see the whole thing front to back. How to build a Rust client for Tiger Beetle, which includes solving problems related to FFI, async Rust, maybe some other interesting stuff. Build system integration. So the Rust client is Tiger Beetle clients in general. All are essentially bindings to a library called TB client. TB client is written in Zig and exposes a C API. So all the existing clients for Tiger Beetle, they also bind to this TB client C library and just kind of expose a idiomatic interface as appropriate for that language. And that's what we're doing in Rust. In the future, it could be desirable to write a pure Rust Tiger Beetle client for various reasons, but the path of least resistance right now is to get one that just binds to the existing library. And this is, we've had a number of episodes so far, and we've gotten a little progress. Most recently, we've been working on creating async client methods for submitting operations or requests to the Tiger Beetle server. And we've implemented 2 so far. And there's maybe 6 total, not sure. But once we have the basic pattern down and we're happy with it for the methods we've already implemented, then we will be able to kind of repeat that pattern for all of the Tiger Beetle operations. So let's go ahead and get started, switch to the code, and just see where we're at. It's been more than a week since the last time we hacked. And generally, every time I sit down fresh to a project, I gotta spend time catching up. All right, so my workspace is, this is some other branch. We're gonna clobber all this. And then we're gonna switch over to the correct branch. And maybe first I'll pull my repo just to make sure I've got the stuff. Okay, yeah, I've already got everything here. So I'm gonna check out my Rust client. I'm gonna make sure this local client is synced up with the one on GitHub, which it is right here. And you can see my commit history here. It looks terrible, but that's my process. When I'm just kind of hacking on stuff, I create lots of temporary commits and don't care too much about the history. And once I get closer to a pull request, I'll think more about how to make the history look presentable. Give me 1 second here. There's so many things to think about when you're streaming. I had two of me in my monitor, so I was hearing a very annoying echo. I had my direct monitoring, and then I had my processed vocal chain monitoring. And my direct monitoring is pretty much instantaneous, but the processed vocal chain has a few milliseconds of delay because it's going into the computer and then back out of the computer again. So it's like just hearing a tiny echo on every single thing I'm saying. What I think we need to do here, okay, lost my train of thought talking about streaming AV stuff, which is a new passion of mine. I'm a new streamer. I don't have a lot of experience, and I'm finding juggling everything is quite a new challenge. We got to do the video production while you're also, doing the performance. Like at the beginning of this stream, I forgot to have the audio on the title card. So I had like 2 minutes where the stream was silent. Anyway, back to code. Let's open up our something into our client Rust directory. Just see what we got here, and I'll make sure this is all text is properly sized for you to read. Let me know if it's not. And I think, again, I have to kind of catch up with where we were last time. So I checked out the branch, and let's go rebuild everything and make sure we got the build all correct. And on this project, there's 2 build components. There's the Tiger Beetle TB client library, and then there's the Rust crate. And eventually they will be part of one build process, but so far I have not done that. And so I have to go rebuild TB client. And the way we do that in the Tiger Beetle build system is build clients C, I think. So Zig builds are imperative, basically. You have a build script, and it uses libraries in this Zig standard library to kind of put a build together. So I think this is just a convention of Tiger Beetle, not necessarily a standard type of target. Anyway, there's our client. And now we should be able to change it to our Rust directory and get this building again. I think I just need to say cargo. I'll say cargo check and cargo build just to prime all the caches. Because most of the time in Rust, we do a lot of type checking with cargo check because Rust builds are very slow. Kind of slow, pretty slow, darn slow. So we spend most of our time just running the type checker, which is considerably faster. And we have a lot of dependencies here. So if we just start by running the type checker and then running the build, we'll have all the dependencies built, and they won't need to be rebuilt again for the whole time we're working here. And I think the thing we need to do is just kind of look at where we were, and I have an idea of what I want to do, but kind of talk through a bit what we want to accomplish during this stream. And again, I'm doing this whole project on stream, so I might think about it a little off stream, but anytime I want to write any code or even kind of do research into what to do next, I'm trying to do it on stream. So here's our client. And for streaming purposes, I wish I knew how to collapse these method definitions in Emacs. There's surely a way, but I don't know. My IDE savvy is pretty minimal. Here's our client. Create a new client, and we have 2 query methods here: submit create account and submit account lookup. The account lookup is about the simplest type of query in Tiger Beetle, so we wrote that first. And then we just kind of use this as a template for doing this slightly more complex query, submit create account. And you'll see here there's a lot of duplication, and that's fine for now. At some point, we'll probably want to start factoring a lot of this out, because maintaining this over time with this duplication is going to get challenging. And a lot of this is unsafe code too, which is quadruply challenging. Now, if we recall from the last time we hacked on this create account method, or the create account Tiger Beetle operation, it supports batching. So you can have many create account operations in one message to the server. The other one here, account lookup, does not support batching. But one thing, I'm going to point this out really quick, that we're going to have to be thinking about in the coming weeks. Let's go look at our browser. There's a PR in for Tiger Beetle that changes how batching works. Let's go to Tiger Beetle and just scroll through here and see if we can find it. I know this is by K. Prati at this one. So I said I don't do like prior research off stream, but I have read this. So this PR is going to change how batching works within Tiger Beetle, and almost certainly this changes the internal interfaces used by the client, the interfaces presented by the TB client library. And we're not coding to this PR. I don't think this PR is done yet, so I'm not going to worry about it right now. But whatever we do now is probably going to change, but I'm not entirely sure, because I also know that the TB client library does, for the most part, handle batching internally. You can submit multiple requests to the client, and I don't know the details, but like if it has the opportunity, it will batch up those requests into a single message. And last time when we ended, I was very confused because just looking at the data types involved with, let's go back to our code. Data types involved with the create account request, it seemed like I needed to handle the batching myself within the Rust bindings to TB client. But I also know that internally to TB client, from previous research and also asking people who know more than me, that the batching is handled internally. And so I'll show you what I was confused about. This TB account T, this is the result. This account lookup OK is, my data type I defined for the return value of looking up an account. Oh, this is not the right request though. Let's go up. Scratch that. This create account OK. This is the batchable request. And this is the return value of a completed request. This is returned like if you successfully talk to the server, this is the result you get. There are also other error cases not accounted for by this type if like something goes wrong client side. But at least as we've defined the API right now, like if you get a response from the server, that's a okay result. But again, this TB create accounts result T is kind of interesting because this is, I'll show you real quick. I think we have to go into, let's look at this is the Rust bindings. These are generated bindings to the library. And there's quite a few files involved in defining and presenting and translating the interface to TB client. So sometimes it's useful to look at the Rust bindings, sometimes the C bindings, etc. But if we go search for TB create accounts result T, this result type supports multiple create accounts requests indicated by index here. So in the message you send to the server, you're sending an array of these requests, and any of them that are successful as an optimization, the server just doesn't return any result for it because it's just more data across the wire. But failed create account requests get a TB create accounts result. And this index is how you correlate the result to your original index of your requests. So this seemed to indicate, because this is what we have to receive back from the client. So when we submit a create accounts request, the client gives us back this. And so this seemed to indicate to me that in my bindings, I was responsible for dealing with this index and the correlation and submitting multiple requests and handling the correlation of the index back to the request. But I'm thinking that's not actually the case. So this led me to think like maybe there's two kinds of batching. Like there's like the manual batching of this particular request, and then internally there's some further kind of automatic batching. I no longer really think that's the case. And I think this interface, this kind of misleading interface, is just kind of a fallout from Tiger Beetle's philosophy of how to define its data model and its interfaces. Like Tiger Beetle is very focused on efficiency and kind of exposing the basic model that the database itself uses internally all the way to the user, which has pros and cons. It's very nice for efficiency, and it's also very nice for kind of letting the consumers of the product. Give me a second here. I thought I was going to sneeze, but I didn't. So expect that to come back again in the future. But now I got a cough. So this kind of surfacing of the underlying model directly through the interface to the consumers, it's really nice for helping, exposing and understanding, helping the clients understand what is really happening within the database. Like there's nothing hidden, right? Like what you see is what you get here. But a downside seems to be that, this is the structure. Even though the client internally seems to handle batching, it's returning this structure that is kind of the internal message type used by the server and exposing the fact that there's like batching going on in this index to correlate batches. So I think that's what's going on, and I believe I don't have to handle batching. So kind of the first thing I want to do today is kind of read through the batching code in the client and try to confirm my hypothesis here. A lot of what we've been doing in this project is looking at the interface presented by TB client and making informed guesses about what it means and what it's expecting and how it's going to behave. And then kind of experimentally testing that hypothesis about what we think the TB client is going to do. And so far it's worked out very well, which I take as a good sign. Like it looks like it's Tiger Beetle. It seems to be designed in the way that my pretty experienced programming brain would expect. And we haven't run into a lot of roadblocks. And then occasionally we dig into the source code and try to see what's going on. But for the most part, it's all behaved like we expect. So the first thing I want to do today is just read through the batching code in the client a little. And if our hypothesis is confirmed and we don't need to do any batching over here in this submit create account method, then we're kind of free to move on to implementing the rest of the Tiger Beetle operations. But we're probably going to go and kind of clean up the interface here a bit so we're not exposing these raw C types directly to the Rust client. Probably, but I don't know, because like the philosophy of Tiger Beetle is to expose these raw types, but probably we're not going to do that in the Rust client. Like even if we do expose similar types here, we're probably going to redefine them in Rust. Like even if we expose types with the exact same field definitions as the C structs, Zig structs, we'll probably redefine them in Rust because multiple reasons. Then we can attach whatever interfaces we want to them, our traits. But also we won't have the docs exposing like the underlying C definitions, which look non-rusty. All right, so anyway, let's go see if we can remember where the client code is. And I think it's all in this C directory. Like most of these directories are bindings. All these directories are bindings. And the C here presents a C client, but it's a very low level C client. And I suspect nobody is writing C. Well, definitely people will be writing some C++ clients, and I guess they'll have to use these. But this is legitimately the implementation of the client. And if we look in lib, maybe, no, that's the output. TB client, this has got to have it. Yeah, so a lot of TB client is defined here in context. Real quick, we'll go ahead and open up tbclient.h. So this is the generated C code, and then tbclient.zig. The generated C code is kind of generated from this code, but not necessarily, not exactly, not one-to-one. There's several files involved, like tbclient header. It might be generated directly from this. No, I don't know, whatever. Let's not get too in the weeds on how the code generation works. That's several episodes ago. Let's go here to context, and I think most everything we're going to care about regard to batching is in context. And in our other window, let's go ahead and open packet. So this is kind of the core data type involved in interfacing with the TB client library. We're submitting our bindings, or submitting packets to the client, and then it is converting these packets, which are kind of misnamed, it seems, to messages, and those messages are what are sent to the server. So this packet abstraction, it's either contains one operation or it contains a batch of operations. And another reason that I was thinking that, you know, some of these requests have to be manually batched is because there's a data size here. So these data and data size define, along with this operation, define the operation we're sending to the server. And this data is an opaque pointer. This is polymorphic. It can be a pointer to any operation defined by this. So in Rust, this would be like operation plus data would be an enum, basically. And but there's also that, like, you could imagine for a single element, you could just know the data size of this packet based on operation. You know, you switch on operation, and depending on the operation, it should be a static size for that packet. But there's also this data size field, which seems redundant in that case. So I was hypothesizing that this data size field is used to indicate to the client that we're actually submitting multiple operations at once. Because with this data size plus the operation, you could figure out the size of that array for a particular operation type. But I'm still skeptical that this is the case, that the client cares about buffers, accepting buffers of operations. So I'm going to go to context. I'm going to go to client first, I think, if there's a client here. Is there a client here? Client? Nope, there's not. Must be in context. We can go up to TB client. So what I want to look at first is the submit method that accepts that packet. And I want to see what it's doing with this data and data size. And then we'll go see if that leads us to batching or not. So there's somewhere here, there's probably a submit function. And you can see it just defers to, this is also polymorphic. There's two different implementations of context. And I don't know the difference between them yet. But if we go to our context, we'll see probably there's another, submit right here. This is the submit function for the main context type. The other context type is called an echo context. And I can only assume what it does, but I don't know. So let's see what it does with this packet, and specifically the data fields in this packet. So we're just going to read through. And you can see there's some shutdown code here. And you can see there's atomics involved, which indicates that this supports multi-threaded submission at least. Okay, we have the message, client get message. So this is, probably getting a message buffer, the thing it's going to actually send to the server. There's probably a cache of these internally, I assume. All right, and here we're switching on the operation. And the message header, we're probably dumping a bunch of stuff in here. Client release, client ID, cluster, request is 0, because we're going to set that later. The command is the dot request. Oh, the command is dot request. So there must be different types of messages even besides requests to the server. I don't know about that. And here's our operation. We're getting the operation, converting it from a integer to something else. Kind of curious what else it would be converting it to here. Well, we can look at that. All right, let's go look at the state machine. All the core data structures in Tiger Beetle are defined in the state machine. I mean, not all, a lot of them. The state machine is like the central piece of code within Tiger Beetle. And like I was saying before, a lot of these data structures work their way all the way up to the surface level of Tiger Beetle because it's very flat design. So let's go look at this method, operation from. Just see if we can find a from method in here. VSR operation. Well, didn't see a from method. Let's go look at operation. Oh, here's operation. Is this operation? I don't think so. VSR operation. I think this operation here inside the state machine is this operation here. So that's just converted trivially from an int to a zig enum. But then this is something else then. This is a VSR operation converted from a state machine operation. So I don't know anything about this. Let's just go look around for a operation type here. Okay, this is interesting. So the VSR, which is the state machine replication algorithm. I don't, trying to remember if I remember exactly what VSR stands for. Ask somebody that knows more than me, but it's the consensus mechanism. So we're probably converting here, I would guess, from the client level messages to the internal cluster level messages. And here's the from method, check state machine operations, return. Okay, it's just more casts. Kind of. State machine operations. This is a state machine operation. Let's go ahead and look at our operation back in our state machine. I'm just curious here because these are, the protocol level, client protocol level messages I expect. These values of the VSR operation are different. Nothing like that. But I see a cast here. So there's just a very simple cast from the state machine operation to the VSR operation, which on the surface seems wrong because semantics of these don't seem like the semantics of these, and the numbers are different. I don't know if I'm going to stick around to actually figure out what I'm not seeing here, but interesting. Chat, if there's anybody there that knows Tiger Beetle better than me, which I do not know Tiger Beetle very well at all, just let me know what I'm missing. But we're getting too far into the weeds for our original purpose. I gotta not just sit around being clueless. Let's go back to our context. And what were we doing here? We have a submit method somewhere. This one. What were we even doing here? We were going to look for how the data pointer and the data size are handled. So let's just Google for packet.data. Okay, it's not in the submit method. Here we're in the on submit method. How did we get to on submit? context implementation on submit. There's some kind of callback thing going on here. This is probably related to the fact that there are multiple contexts and there's some ad hoc type of polymorphism going on here. Yeah, you can see that on submit is not called from this file. So if we go back to tbclient.zig, I bet we will see it here. We don't see it there. Let's Google, not Google, let's ripgrep. On client, cd, c, rg, on submit, not on client. Oh, it's not. Oh, you can see. This is, here's a little bit of a comprehension fail and or a design fail. This on submit method is converted to a field called submit function. So I was grepping for on submit, but what I should have been grepping was for submit function. You know, it's an interesting, somewhat trivial design question there. Like, should these things be have the same name? But it doesn't matter right now. I figured that out pretty fast, right? Here's a recall submit fun. Some kind of type definition here for submit fun. And the TB client, as we surmised, is responsible for calling submit fun. Okay. So, interesting. So the top level submit method, this is the method that we're calling in our bindings, are calling the submit fun. But if we go look at context, there is a submit function right here. And this is not the function that we're calling yet. So if we trace through our call stack, we actually haven't gotten here. We need to be looking at on submit. Who calls submit? Now the question is not who calls on submit, it's who calls submit. So when we submit the packet, we assign, wow, this is fascinating. All right, so here's our packet. This is the thing that we created and passed into the client. And immediately, you can see packet is caller allocated. This user data is reinitialized to what we already said. I wonder if this is just because there's not like a struct update syntax in Zig. That's probably the deal. Like in Rust, you would, if you just wanted to update some fields of a packet, you could do something like dot packet, something like that. This is probably the case here, that it just has to repeat all the fields here. So this is literally the same thing that we initialized this packet with. This is just seems to be just defensive, kind of making sure the things that need to be a certain way are that way. Like status needs to be okay. These all need to be null. Batch size is 0. Interesting. Okay, then we get context. Don't know what that is. Oh, right. This is, more ad hoc polymorphism stuff. Ad hoc polymorphism is the wrong term. I know that actually means something. This is some kind of handwritten polymorphic code. It's getting the actual self value out of this implementation here, which is kind of a super type. And then submitted push. Okay, so here's the deal. The submit on submit, when we submit something, no work is actually done. When we submit a packet to the TB client, it just kind of pushes it onto a queue for later work, and then, emits some kind of signal that it's ready to do something. And this is surely asynchronous here. The work is going to get done probably off thread. The way the TB client works is it puts a event loop onto some other thread and does its work there. So when we get callbacks later, they're on another thread. And as we discussed in a previous episode, the Rust client immediately sends messages back to the original thread to handle its side of the response. So there's 2 threads involved at least. Okay, so this just submit some, it queues up the packet. And this is touch data size and data, but still not doing anything with it. So probably, if we go back to context again, this submit function, we can see that again, data is not touched here at all. It emits a raw request. Here's some batching code. The data is not touched. Oh, there's data. There's data. Didn't I search for this before? Okay. I was searching for packet.data because up here, our variables are named packet. But the batching code itself, which is the thing, if you recall from like 30 minutes ago, that we are interested in researching, the batching code iterates over something, and then it's handling the data. So batched, iterator is a data. It's assigning the packet to this. Okay, I remember this code. So it's assigning this packet to this maybe thing, which it stands for iterator in this case. But this is an optional pointer to a packet. And it's named iterator, but it's a little confusing because it's kind of a manual iteration going on here. And it says, if that packet has a value in it, then we're going to do something. And somewhere in here, it's going to possibly reassign this pointer. So it's kind of like a very open-coded iterator here, which is interesting. You don't see this pattern a lot in higher level languages. They'll just have an iterator somehow. Let's see, where's our loop is here. It's right here. So batch.next, if there's another thing in the batch to handle, it'll keep going through this loop. And you can see, I don't know if I want to dig into this too deeply because we've looked at this before. But basically this takes the things in the packet and mim copies them into the message. And as long as there's things in the batch, it will keep doing that. And so that raises the question of who sets this batch.next. And what I'm hoping is batch.next gets set in cases where the operation is batchable. So that includes our case from our bindings that we're writing. Let's go back to our bindings, the create account. So what I'm hoping to see is that somewhere in this context or somewhere in the client library, there's kind of an analysis of the stacked up batches. And it will attempt to batch them if it sees multiple create account requests operations in a row. So I'm expecting the batching mechanism to be like, here's our list of all possible packets we've queued up internally. It'll scan forward. And as long as they are, if it's looking at a submit create account, it will just do like a, kind of a run link thing where it looks through all the create accounts that sees directly ahead of it and put those into a batch. And then when it sees another type of operation, it'll be like, I can't batch this anymore. So that's kind of what I'm expecting out of the batching. So somewhere we have to figure out where it's doing that. And I'm curious, it's probably before this is called. There's probably like an opportunity to kind of look at the packets we've got. But I want to go back to that onSubmit method because that onSubmit method establishes like the queue of packets. You can see here next, there's two linked lists inside this packet that are managed by the library. They're not managed by the bindings. There's next, which is just clearly a linked list of packets. And then there's the batch next and all this batch stuff. So what I'm expecting again is when you submit something, it's going to like look onto its last packet pointer, which must exist somewhere, and then set it to the next pointer inside of that to the new packet. So it's establishing like a queue. It's probably in a FIFO type. Tigerbeetle uses a lot of intrusive FIFOs. First in, first out queue. And then at some point, it does some kind of analysis to like do that scanning through the queue to establish batches. And it might even not even just like do like a run link thing where it just scans immediately forward. It might skip forward when it can, like if it sees a bunch of submit create operations and then like maybe a immutable operation, it might be like you can imagine it skipping over some operations if it understands the semantics. It's okay to skip operations and then like pull in more and more create account operations into a single batch. So that's our hypothesis. And on submit, this is the thing, again, that is called by our bindings. We're pushing it onto submitted. And I'm guessing submitted is going to be a FIFO. So let's go look for the submitted field. And it's not directly a FIFO, it's a submission stack. I'm wondering if I actually care to look at the submission stack. Maybe because like maybe the submission stack handles the batch as well. So let's look in packet. It's pretty reasonable to assume that the batch handling is in this packet namespace. And here's our submission stack. Again, this has got a bunch of atomics, so this is going to be accessed from multiple threads. Almost certainly what's going on here is that you can push from multiple threads and pop from one thread, which we're not going to use in the Rust bindings. But we, maybe after the first iteration, we can think about how to kind of multi-thread the submission in the Rust bindings, but it doesn't really seem to me like it's going to be desirable. That's not how you write Rust async code generally, though you could share a client across threads in Rust. But I'm hopeful that a single thread is enough. Let's not get too far into that. Let's keep on task here. So here, submission stack is not handling the batching. I don't see any batching code in packet. This is just basic type definitions. Let's go back to context and search for batch next. All right, we've seen this code. What is this method here? On result. So this is handling the response from the server. I don't want to look at that yet. Cancel, okay. On submit. All right, it's got to be this right here. This looks very promising. This is the request method. Who's calling the request method? Okay, before we dig into the batching, I just want to know, what this call stack looks like. Where does request get called from? Search for self.request. Yeah, I have so many tangents I want to talk about related to Tiger Beetle and Zig code patterns, but I've got to keep on target here. On signal. Okay, so probably your other thread you saw in on submit, it emits some kind of signal, and probably in the work thread, then it basically ends up calling this at some point in the future. Then we call self request for the packet. And the request, this is where it's going to do the batching. I'm not going to care too much about this, but here's the event size. And again, it does get the event size from a switch on the operation. So that leaves the question of what is the data size for? Make sure the packet data size is correct. So it seems like it knows if packet data size is greater than 0 events. Break data. Okay, this is events. So this suggests there are multiple events within a single submission. So within a single packet. Empty arrays, okay. So here's our events. And returning this data sliced from packet to data size. So this is just converting our raw opaque pointer to a slice of bytes. Nothing special about that yet. Okay, and so, yeah, it is doing what we previously thought it would do, where it uses that data size to figure out the number of events in a single packet. So if events, okay, this is saying if the length of the events, the length of the data size pointer, or the length of data size, data size, the lengths of the buffer we've submitted with the packet is not right for the event size according to the operation, then, it's an error. So this does suggest that we can submit multiple operations or multiple events of a single operation within a packet. Events batch, self.onComplete, too much data. Okay, here's batch next equals null, batch tail equals packet, batch size equals data size, batch allowed, batch logical allowed, packet data size. Okay, this is, got it. Okay, so basically for any operation, we as bindings to the client can submit multiple of them. And then the client will decide, like, if this is the type of operation that can be batched, it will batch them. This batch allowed says like we're allowed to use a batch or not. Batch tail, batch size is packet.data size. So now what I'm wondering is whether the batching is done within a single submission or whether it batches across multiple submissions of the same operation type. But this here indicates that, like, if we submit 5 operations of a batchable type of operation at once, they will get batched. Batch tail, batch packet size. So this is kind of like initializing a linked list, but it's not part of a linked list of packets yet. So you can assume that there's still going to be another step that kind of links these packets together, and the packets could contain multiple events, but then we'll link those packets together to contain even more events, hopefully, is what this indicates. Nothing in flight means the packet should be submitted right now. So we just submit it, right? So if we're queuing up packets, then we have an opportunity to coalesce those packets into a single message. So if it's allowed to batch, okay, this is it. This is the stuff. So if this packet, which could contain multiple events of a same operation, so if that operation type can be batched, now it's going to do the business of scanning through the linked list of packets, trying to do even more coalescing. And we're almost at the point where we're like, we know how this works, but it's just, let's read through this and make sure. So self-pending.peep. Yeah, so it's going to look at what's pending. Presumably that's the next packet. I'm assuming they're going to maintain order of packets, like order of the packets that we've submitted. So this packet that we're all currently working on is going to be at the end, I would assume. And here we're going to iterate over the same pattern here where we have a mutable maybe value, optional value. And here we set it to the next one. So root.next. So this presumably, I'm guessing this is just going to scan the entire queue of packets. So first in the queue, the next packet to go out, and then we set it to the next. So we're traversing a linked list of packets. And here we say, okay. Here we say, if it's not the right type of operation, then we definitely don't care about this packet in the list. If not root batch allowed, then we don't care. That's interesting because we had already decided up here whether the batching is allowed. And I assume this is based on the operation, but it's also based on the packet data. So probably if this is already too big, then it's not going to allow further batching, which gets short-circuited here. Merged events. Div batch size, packet size. So this is how many events it would have to merge. And if it's going to be too much, so it's going to merge whole packets. It's not going to try to split a packet up into multiple packets. It's just going to take two packets that are adjacent to each other and just treat them both as a merged message. Yeah, and then it establishes a linked list, adds a thing to a linked list. Okay, that makes perfect sense. So let me take a drink and I'll try to collect my thoughts. Whew. So far, we have our objective today was to kind of understand how batching works inside the client in order to figure out whether we have written our client submit methods correctly. And we haven't. The submit methods are incorrect, so we're going to have to do some rewrites there. And that'll probably be the next thing we do, because I wasn't certain whether coming into this, it looked like there were two kinds of batching involved. Like we, as a binding to the client, are allowed to submit multiple operations at a time, but also internally to the client, there is batching going on with this linked list of packets. And it seemed like, why would we do both? But it is the case that there are two kinds of batching here. So the client is expected to submit it is allowed to submit as many operations of the same type at once as it can. It could submit one packet, one operation at a time, one operation per packet, and the batching mechanism within TB client will coalesce all those packets into one. But the obvious downside is that there is allocation involved in submitting a packet. So if you can cram as many operations as you can into a single packet, then the performance should be significantly better. Depending on the trade-offs we make, the performance, either like the runtime performance or the allocation space performance, because we're going to have to, at some point, do some optimizations here to reuse packet buffers and other types of allocations involved in the submission of packets. But it does seem like as a Tiger Beetle client consumer, you should be trying to take as many operations as you can of the same type and stuffing them all into one packet to submit. So that suggests to us that we have to make some significant changes to what we've done here in the API, but not necessarily huge changes. Right now, our API that we've designed submits exactly one operation per packet, and we need to change that. So this has been, very productive right now, this research. But we got to make, let's see, I see my context buffer is dirty for some reason. There we go. There's some Emacs temporary files just hanging around. And chat, I will switch back to terminal. Sorry about that. So now the path is pretty clear. We just got to go back to our library and redesign it again. And before we start redesigning our library, and again, we're going to go down to, this is the more complex operation. So we're going to start with the simpler operation and look at, we're going to run our test program. So we also, besides the library, we have a little tiny manual test harness. This is just for exercising the library while we're hacking on it, not a literal test, not like a unit test that we're ever going to check in. I just want to compile and run this and make sure that it, I understand what it's doing now before we start changing the library. So I'm just going to say cargo run, and this isn't going to work because, no server running. And over here in Tiger Beetle land, we have a test database built already. I think this is okay to keep using. And we'll say zig build. Build is our zig build script. And a run command will run Tiger Beetle. And we'll say start to run the server. And we'll just ask it to tell us the next flags to get the server running because I don't remember offhand. Addresses. So we have to tell it the addresses to listen on. I'm just going to tell it one address. It could be nice to like default this. Also, you can't type localhost here. Oh, maybe you can. I suspect not. I suspect that will fail parsing at some point. But maybe somebody's added support for basic DNS or something. But I think you can't use any kind of DNS names right now, including localhost. Okay, so our server's running. And in our test function here, we're going to run it, but I suspect it's going to still fail because of duplicate ID names. Yeah, but you can see right here the first request we made. We're trying to create accounts and then look up accounts, and the create accounts errored because it already has ID 11 exists. So I'm just going to make this ID 12 and run it again. And these should be 2 successful requests. Yeah, there you go. And why is context dirty again? What's going on with context here? Context.zig. Oh, I know. I tried to clean this, but I was in the wrong directory. This is in a parent directory. So if we go back up here, get clean. Yeah, there we go. So I remember now what let's go ahead and commit this. Although that number is invalid now again because that account ID is invalid now because we now have another one in our test database. This would be more convenient if I randomize this number, but I'm not going to do it yet because we're probably going to spend the rest of this stream just type checking stuff, not running code. And this really should be pretty easy. So the one thing I'm a little concerned about here is this account lookup, the result type here. What is the result type here? You get the result back, and if it's empty, the account lookup was not found. Okay, so basically for every type of batched lookup or batched query, generally in some cases, the result will be completely empty, and then in some cases it won't. And here, if the result is not found, we don't get any result returned for that specific op or that specific request. Event is what they call it inside the client. So that specific event won't have a result. But then where it is found, there will be results. And that means we're going to have to go over this list and kind of correlate the results with each other. And that means with the results that have a value, there must be some way to look inside and say, like, this result corresponds to this event in the request, which also suggests that we need to be able to hold on to the request and look at it again. And inside of the TB account, the account lookup result, clearly there's going to be an ID inside of this TB account type, and we use that ID to correlate with the ID inside the account lookup operation. So what I would like to be able to do, what would be really awesome, is if I could keep this code for handling a single submission and then wrap that in code for handling multiple submissions. But I kind of don't know if that's going to be convenient to do or not. Could be doable, but I think the code for the submit a single account will end up changing. Because you could imagine it'd be very nice it could be convenient for callers to be able to submit one thing at a time. But then again, so you'd have two methods for every operation, like an operation that is kind of simple type wise and that submits one event, and then a more complex method that submits an arbitrary number of events. But that's probably not very Tiger style. Probably we want to make the user confront the fact that they should be submitting multiple events if they can. So I don't think we'll do that. We'll probably just have one submit method for each operation that takes a slice, probably. So I think what we're going to do is we're going to kind of take this, leave it in place for reference, and then just kind of start over. I'll kind of copy the skeleton of this function signature. And then I'll just throw a panic in here, not to do in here. In this account lookup operation, we're going to need to go see what we have here. Account lookup operation. So every lookup operation is actually just a U128 account. And we've discussed on stream before that this is probably too much abstraction. There's only one field in this operation. Likewise here. So the idea of defining a new struct for every type of operation, it's kind of clean because then we can give them all similar names, like this is an operation and this is the result, the OK result of that operation. But probably we're not actually going to end up doing this because it's just kind of extra boilerplate to write this struct every time you call submit account lookup. You might have to, for example, do a bunch of pointless mapping from user 128s because the user's app is going to be in terms of either their own data type or just U128 IDs here. And having them wrap an array of U128s into an array of account lookups is just going to be extra work. So instead of account lookup operation, I'll go ahead and change this to a slice of U128. And I know there's going to be bounds on how many units you can have here. And for now, we're just going to say, probably going to submit whatever the user submits here to TB client. And then TB client is going to call us back with an error. And then we're probably going to translate the TB client FFI error into a higher level Rust error. So we're not going to kind of have any guards here about this being too big. But you could imagine having static bounds on the type accepted here that just eliminates that whole error condition. But we're not going to try to do that right now. That's a trickier thing to do. So we have our array of U128s. And it's going to return not an account lookup OK. I'm kind of wondering whether I'm going to return, again, I think we still need for every event in this submission, this request, we're going to have to say this was found, this was not found. I think in our bindings, we want to do that correlation between the result array and the request array for the user, because that's pretty tedious and error prone, and I don't want to force everybody to write that. So we're going to probably have to convert the result to either an iterator for every single thing submitted or an iterator for an iterator for every request submitted, event submitted, or a vector of results for every request submitted. And if we think about how the client is going to want to use this, we want to make it easy for the client to figure out this result was for, this case that I was dealing with. So really, we're going to want to tell them for every element in the array of packets you submitted, here is what happened with that packet, which could be an error, or it could be, in this case, either a found or not found. And we're probably going to want to tell them, we might want to hand them back their original request, because that might make it much more easier for them to deal with, like, oh, these are the request and the response pair, so I know what I was doing. Otherwise, they're going to have to kind of go reconstruct, what they were doing with the original event. So offhand, I kind of want to know where this TB account T came from, if this was literally part of the response, or if we handed them back their original payload here. I kind of think, yeah, this is part of the response. So let me just spitball here some design. I'm thinking the general form of the response we're going to want to hand back to the user in our high-level API. And this is discarding any submission errors. Those are handled separately by this result. So this is kind of an error for the entire packet. And we're thinking more about the results of a single event within that packet. And it's probably going to be an enum, account lookup. I'm going to call it OK. I don't want to call it result, because then we're going to be dealing with nested results here, the semantics of which is kind of confusing. I want to say this is the OK case, but again, there could be kind of like database level errors here, like server level errors still. Yeah, interesting. And for this one, we're going to say like maybe, okay, I don't want to necessarily say, I want to hand back the result for the request, but probably also the request itself. So the result for the event and the event itself. Because I suspect there's going to be more information in the original event than in the result, and the user might want that original information back. It's not the case with this specific request. So maybe we'll handle that when we come to it. Maybe we'll handle that when we come to it. But I was thinking something like request and then account lookup operation. And then another enum in here to represent this. But we don't need it for this particular request, for this particular operation. So let's not do that prematurely, because our assumptions could be wrong still. So again, I'm going to make this account lookup OK, found, not found. And yeah, actually, I think this is going to work for us for now. For this request, this same result will work. But we're not going to return just one, because again, now we have multiple operations in the same, multiple events. I kind of want to call this events. Internally, the client calls this events. Like this submit account lookup is a single type of operation, but there may be multiple events of that type of operation. So I want to call this events. And then here we need to return a result for every single one of these. And for now, I'm going to make that a vector. Obviously, that's not going to be efficient, because we're going to have to return, we're going to have to allocate every single return value here. You can imagine returning like a slice, but then that slice has to be allocated internally, and it's going to cause things like this to be locked as long as that slice is held. Borrowed. Self will be borrowed as long as that slice is held. And it's going to be very complicated to deal with that. So really what this wants to be probably is an iterator where item equals this. And that's doable. I think that'll be doable, but I don't want to do that right now because it's a little harder. Let's get the basic concept to work. So we'll just allocate a whole vector of the results for these events. All right, let's start writing this as code. So again, chat, we are kind of converting our old account lookup operation, which supported one event at a type, to a new account lookup operation that supports many events at a time. Not equal, account equals 0. And our assumption was that accounts can't be equal to 0. I think this assumption was wrong, actually. I think this is incorrect. So we're not going to keep doing that. So I'm just kind of going through our old code and repurposing it for this new world. This channel is going to be similar. Completion message here is a completion message of U128, and that's going to be wrong. One of the things that, so again, what happens here is this callback gets called back on some other thread, and then it has to convert unsafe pointers immediately back to owned pointers, or else they could get lost in transit from one thread to the other thread and then never freed. And so we're allocating this U128 of the result type. So already here we have to reallocate the results in some way. We have to push them onto the thread. And if you recall from previous episodes, this result pointer we get in this callback is not owned by us. This is owned by the client. So as soon as this callback ends, we got to be done with this result pointer. So really, probably what we're going to have to do is, instead of making this result pointer typed, we're just going to say just copy a bunch of bytes into a vec and send it back to the main thread, and we'll deal with the type conversion back on the main thread. Because if we were to copy this to vector now, then we would have a vector allocated for the results that had a corresponding result payload, but some of the results don't have a corresponding payload, and we have to have a step where we do that correlation between input and output. And if we immediately allocate some things as result types here, well, I was thinking that we could save an allocation, but I'm actually kind of thinking that's wrong. But at the same time, dealing with types here in this callback doesn't seem necessary at all. It just adds more operation-specific complexity to this callback, and the job of this callback is to just make sure nothing gets dangled and get all the data back to the main thread. So whether we're allocating raw bytes or whether we're allocating a type that is specific to the particular operation we're dealing with doesn't matter in this callback, and doing less is probably the best thing. So where previously we were casting this result to a operation-specific type, I don't want to do that anymore. So that means this completion message, we're going to have a different definition for this. So let's go look at that. Is it a struct or an enum? Yeah, completion message. We have no type parameter on this at all, which is good for simplicity. And this completion message, for now, we'll just call it completion message 2, because we're going to leave the old code around until we have the new code working, and then eventually we'll get rid of the 2. This payload, oh, I'm completely wrong here. Chat. I'm completely wrong. So the payload is type specific. This is type conversion has to happen here because the payload is for a specific operation, but already our vec is untyped, or it's just a byte buffer. So all that I was talking about, good context, but incorrect. So here's submit create account. And again, we are copying create account, submit account lookup. And here's our new method, which is submit account lookup 2. And let's keep going. I'm going to just retype it all for comprehension so I remember what we're doing. First thing we do is create a channel for our communication between the work thread or from the completion thread and the main thread. So this is our payload type, our request payload type. And again, I'm having new caveats about this type. So before we were casting, we are going to have to create a new completion message type. Because remember before, our payload was exactly one event, but now we have some kind of vector of events. So this is actually not a box anymore. This is a vec. So I am going to create a new completion message type to handle that. This is more than one. The payload is more than one event, P. And again, since we have a new term here for the things inside of the packet, I might change this to not be payload. I might change this to be events, because TB client uses this term events to represent these individual instances of the operation within a packet. So now there's going to be a vector of events. And this is completion message 2. And so our events, multiple, plural, is U128s here. And let's again go work on our submit message, just scroll down. Submit account lookup. Keep working on our copy paste. And here we construct the packet. And again, there's a lot of allocation in this code, and we'll worry about addressing all that allocation some other time. Here we create the callback that runs on another thread. Completion. You can see there's a double indirection here, which is pretty gnarly, and I'm not going to re-explain why that double allocation exists right now. Got to keep my eyes on the prize here. This looks correct. So here's our callback. And before we write this callback, let's go figure out what this callback is doing. Okay, yeah. So we create this callback. So this is all a big scope to create the packet. The callback is part of the packet. And it's pretty convenient in Rust to just open scopes for this kind of work. Like, this is going to span more than a screen, but it's all involved with constructing this one value. And down here, we create the payload. So I kind of want to go finish this block before we write that callback. And nope, I changed my mind immediately. Result, packet, payload. Changed my mind immediately. Almost all of this is going to be the same code for the callback, except we just changed the type of this payload. Payload type, so U128. So instead of being a box, this is going to be a vec. And this assertion is wrong because this data size is a multiple of this size. And this assertion is unnecessary too. Like we could write a new assertion for this, that it's a multiple of mem size of, But this code will never get executed if that's the case, because as we saw before, TB client is already handling that case. TB client's already handling that case. So let me make room on my screen here so you can see this full line. Instead of the box, we're going to say events, because we changed the name to events. Down here, this is events. And I'm making lots of S's sounds. That's not super great. Vec from, oh, what is this? What is this? This is going to be Vec from raw parts. We're gonna, we might have to go. This would be easier to write if we had written the corresponding code down here that constructs that Vec and then converts it, casts it to an unsafe pointer. And this Vec from raw part, this event Vec is going to have to be allocated separately from the slice that the user is submitting. So again, another inefficiency in the allocation that we're just going to have to think about harder some other day. And real quick, let's just go back to the web and look at the Rust standard library to figure out how to get a Vec from an unsafe pointer. It's probably from raw parts, but let's see. Vec from raw parts. Yep, that's it. And back to our code. So here we're going to say, instead of box from raw, we're going to say Vec from raw parts. And this is going to be, this might be a complicated expression. The pointer is packet.data. And this is a length in elements. So in Rust, the length of a slice and or vector is stored in elements, not in the length in bytes. But the data size in TB client is the opposite. So we have to do a little bit of a conversion here. So we're going to say events. I'll make it a separate expression so it's a little more readable. And then we don't need multiple lines here. Len, not whatever I wrote there. And here we're going to say the length of the length in elements is going to be data size. Oops. Yeah, data size. Packet.data size. And I don't know if I have to do this dereference. Let's go back up here again. Yes, I did. So here's where we're using data size in the previous code. So down here, we're going to say the data size divided by the size of a single element, which is going to be mem size of U128. And as I'm writing this, I'm kind of wondering if I can create a type def to represent this U128. This is our payload type, or our event type, because it's repeated here several times and it seems error prone. Mem size of U128. And that should give us our element length. So then we create the Vec, and at this point, we own that buffer again. Now TB client no longer has responsibility for that buffer. And we're going to null out the original unsafe pointer just, to make sure nobody touches it, because we're not allowed to touch it anymore once it's owned by Rust. And that looks like packet, TB packet T, then the result type. We're just copying it into a Vec. All right, this looks like all the changes necessary for the callback. So again, let's open up our previous method that we're cribbing off of. And let's go construct this payload. But actually, let's put a to-do here and just see if we can build. Cargo check. We can't build. That's typical. All right, let's fix these compiler errors. Compiler. And we haven't type checked this in quite a while. Okay, some casts needed here. And I've been using a lot of unsafe casts here, or lossy casts here. This is a use size. And these lossy casts, you got to be careful. Like if you write one of these basic Rust casts, some of them are lossy. Kind of a design word in Rust where it's so concerned about precision. So anytime you write this, you got to like think, could this be lossy? And in this case, there's no way because this data size is a U32. But this data size represents the length of the array in bytes. So on a 64-bit architecture, which is what Tiger Beetle is run on, I don't think it even builds for 32-bit architectures. The size of array cannot exceed 32 bits in resolution. So there's no way this will ever fail. But if this does fail, right, it's lossy and you'll get a crash. It'll crash. So usually when I'm writing conversion code, I will use a safer type of cast. But for now, I'm using as is. And maybe before we submit this for a PR, we'll go back through all these casts and like put safer casts in. But, you know, often when you're kind of just prototyping, it's so much easier to write this because the safe casts are more verbose. Yeah, kind of a wart in Rust. You'd want it to flip that around, make unsafe casts more verbose and safe casts easy. Okay, we're dealing with compiler errors right now, so I think we got that one solved. Can't divide, okay, that's the same error. From raw parts takes 3 arguments. And events len is a U size. I fixed that. There's a 3rd argument of from raw parts. Okay, we're gonna have to go back to the standard library docs and figure that out. Where's my browser? Oh, it's this one. Vec from raw parts. Oh, capacity. Length and capacity. That's interesting. We got to make sure we don't screw that up. Because the vector also has unused elements in it. And the information we've passed to the Tiger Beetle client inside the packet does not have any room for extra capacity. We're passing the length and the pointer. So that means outside of storing more information somewhere else about the capacity, this vec must be perfectly sized. Good to note. So when we construct this vec, it has to be exactly right sized. That's going to place limitations on like reusing buffers and things like that. But there is a user data pointer that we can always stuff more data into, including a capacity for this particular buffer if we ever need to. But for now, we'll just make the assumption that our buffer is perfectly sized, which means we should probably go throw in an assert while we're thinking about it. And so this event's capacity is also the events len. And then way down here, well, we can't write this assert yet, but we're going to say to do assert capacity equals length, because that's somewhere we could definitely make some big mistakes. I actually don't know what happens if you put in the wrong capacity unsafely to a vector. I think the allocator will probably most allocators will probably see that that is incorrect later at free time and probably abort. But I don't know. We'll just make sure we do it right. Okay, so again, we are still just focused on building. Let's keep trying to build. Events, completion message does not have this field because this is a completion message 2, not a completion message. I must be getting tired. Words are not coming out right anymore. All right, mismatch types events, expected 128, found void. That doesn't seem right at all. What line is this? 240. So our events here, we need to do another cast here somehow. So we're creating a vec of this packet data is declared as a C void, but it actually needs to be a buffer of U128. Let's go look at the old code and see where we were making that cast before. Ah, it's right there. So just casting to a U128 pointer. So this payload, not that one, submit lookup 2. Right here, we need to cast this to the correct type as star mute U128. That seems right. That seems right. All right, that should be the last of our type check failures. Great. Just gonna commit that. And now we can go on to the other side of this method, which is constructing the packet. So here, the big change here is this payload is not going to be the payload. This is going to be not just a box of one thing, but it's going to be a list of these, or a vector of these. And again, I can probably just copy all of this. This is mostly not going to change. But again, remember that we have renamed payload to events. And then this method, this is no longer going to be a vec. I'm no longer a box, it's going to be a vec. Let's say events is a vec of U128 equals who knows yet. And this events is going to be, this is not the right method for converting a vec. I think it's into raw parts. And that means into raw parts? That can't be right. It's got into raw. That's just got to be it. Let's go look at the docs again, just to make sure. Because once we've converted this vec into a pointer, we can no longer access the length and capacity of this vector. And I want to make sure that I just want to see whether there's like an inter raw parts that provides a tuple or a thruple, or whether we need to take those length and capacity and store them to a temporary. So let's go look at the Rust standard library docs one more time. So if we look at a vec, there's going to be, I'll just use the search bar again, we know it's going to be into raw, I think. Vec into raw something, into raw parts. Okay, so you can deconstruct the whole vec and you get a thruple. Oh, this is a nightly API, so we can't do that. Okay, So we do have to store them to a local first. And then presumably there is an into raw that just gives you the pointer, or do you just have to take a pointer? Okay, you just have to take a pointer. There's probably as pointer. Nope. Oh, no, as pointer. Yeah. Oh, yeah, it's right there. As pointer. It's an immutable pointer. Why is that an immutable pointer? Is there an as pointer mute? As mute pointer. Okay, that's what we want. The vector outlives the pointer this function returns, or it will end up dangling. Okay. So interesting. So unlike box, there's not just a function that consumes the vec and returns you the unsafe representation of that vec. That's kind of surprising. And that's why there's that nightly API that does do that. Definitely kind of a missing feature, missing API. All right, let's go back and deal with that. So here we're going to have to say let assert eq events.len events.capacity. Remember, before we were saying this is just an invariant that we're going to have to live with for now, but could be loosened if we ever need to. So that's done. And then here we're going to decompose manually. I'm going to say let events len equals events.len, and let events pointer equals events.as mute pointer. And now we got to forget, we have to forget that owned box or that owned vector. Because part of this is that we are handing off ownership of these pointers to TB client, because TB client is going to be mutating things potentially or reading things unexpectedly. We just want to make the ownership very clear that while the submission is in queued, like, we don't own anything. It's all owned by TB client. You know, that might not be necessary for all of these pointers, but let's just make the ownership very clear. I like that. So I'm going to say mem forget events. So Rust doesn't own it after this, which means we also have to be aware of what happens if there's a panic. So anything here that panics, we're in trouble. We can't have anything that can panic in this code. Or if we do, then we have to write even more complex code to deal with that. And this is all the same. This operation is going to be the same. This is okay. And we're allowed to not fill all this stuff in because TB client does, but still we want to be clear and fill all these in with defaults, nulls and zeros and stuff. And this data is now no longer this. This is going to be events pointer. And already it's a U128 pointer. But then we have to cast it to the opaque type. And this data size is wrong because we're not dealing with the size of a single element, and we're not dealing with the size of multiple elements. We're not dealing with the length of the vector like we are in Rust. We're dealing with the total byte length, which is going to be times events length. And then I think we need parens. No, we don't. I don't know if we need parens here to handle the precedence of this cast. I don't know the precedence of as compared to star. We'll see. The compiler will tell us if it's not going to work. Okay, so that seems right for that. And we still have this to do, but this is enough to type check what we've written so far. So let's just give this a type check. And what? Where is that? callback. Can't find the value of call. Oh, I see. I put this in the wrong spot. This is still to do. This code lives up here. Okay, I typoed this events len. Expected U size. Okay, found U32. So I do need to fix the precedence here with parens. Okay, type checks. Oh, and again, chat, we are in the process of rewriting previous APIs for the Tiger Beetle Rust client from accepting a single operation at a time to accepting an array of multiple operations at a time. Okay, so all the code, oh, one more thing to do here for constructing the packet. Previously, this was just boxing the account, but now it's going to be converting this events slice into an events vector. And interesting thing here, like if we accept a slice here, which is pretty typical for accepting arrays of things in Rust methods, we're going to have to push it up to the heap here and allocate, which is inefficient. So we could make the caller provide a vec here that kind of forces them into a single representation. But it also kind of like pushes that responsibility for allocation up, kind of like exposes the fact that there's an allocation internally. Though, of course, internally, we could also think about in the future how to cache this buffer and reuse it in some way. But also, as of now, this buffer has to have the same capacity as at its length. And so if we ask the user to pass in a vector, they would be very likely to not maintain that. And also this pattern, if we had a vector here, might not work for all requests because this surface representation of the operation in the Rust API may not be byte compatible with the underlying representation or the underlying types that we're going to pass to the TB client. So for now, again, I'm going to accept this inefficiency. We're going to allocate this a vec fresh. And how do I heapify a slice into a vec? I think I say vec from slice. Man, I'm always forgetting things. This is something I've written. Converting a vec slice to a vec in Rust is like bread and butter stuff, but I'm just always forgetting things. And also we remember that we need to make sure the capacity is exact. And I don't know whether a built-in method is going to do that. So we're going to have to be very careful. New with capacity from raw parts. We'll try with capacity from raw parts. This compiler is very smart about this. I'm assuming there's some kind of like private annotations in the standard library that lets it emit these very good error messages about this method that does not even exist. But maybe this is hard-coded in the compiler. I doubt it, though. So converting a slice to a vec, we could say, we try to say events. Oh, the typical way you would do this is by turning the slice into an iterator and then collecting the iterator. But almost certainly that is not going to be a right-sized vector. Though it could be. It could be specialized in a way that it just works and makes the vector the same capacity. In fact, let's just do it and see if we ever encounter any assertions down here. So we're going to say events.intoIter are not intoIter because it's not owned. So iter.collect. I'm very curious whether that is going to create the exact size vector or not. Because in the general case, the iterator is not going to know how many events it's iterating over. But, you know, the iterators are pretty sophisticated and they have specializations. And there's, I think, even iterator types that are like exact size iterator and things like that. So this might like return an exact size iterator, and then collect could be specialized over exact size iterator. All iterators in Rust though also have a size hint. So if this iterator is going to have a correct size hint, it's going to be exactly correct. So collect might not even be specialized. It might just say we're going to pre-allocate according to the iterator size hint. So now that I've talked through that a bit, I'm pretty confident that this assertion is going to succeed. So that's the kind of idiomatic way to turn a slice of things into a almost any kind of collection of things. And of course, I didn't do it right. This is a iterator, but it's an iterator of references to U128. And the easiest way to fix that is to say dot copied, and that will just chain a copying iterator to it. And so now we don't have that problem, but this events is not borrowable as mutable, just because I didn't put a mute here. And it's interesting, this mutable events, we're borrowing it as a mutable pointer. So this has to be a mutable reference. And then we immediately forget that own type. And this type checks, so let's checkpoint our work here. Okay, and again, down here, we got to handle the result of that submission. So it's unfortunate. This code is kind of written out of order. It's going to execute this first. This is the construction of the packet. Then this code, which is the callback that handles the completion, the submission completion. And then down here is the handling of the actual handling of the completion. So it kind of runs, this code runs out of order than the order it's written in. You know, it would be nice to write this code down here to kind of like maintain a straight line order of the code, but not a big deal. Easy enough to understand. So again, let's go look at the code that we're cribbing off of, submit account lookup. So this is previously right here, how we handled the submission and the response handling. So let's just start by doing the same thing. And I think this is just literally the same code. And again, here we are releasing ownership of the packet pointer, handing it off to TB client. So at this point, all the pointers that we allocated are no longer owned. All right, give me 1 second, chat. I'll be right back. I'm back. Okay, so I just had to take a sip and clean my glasses. I'm seeing another smudge on my glasses, but too late. We're gonna stick it out. Okay, submitted that thing. And again, just we're waiting for the message that the packet has been handled. This is all the same code. This is the error handling for the top level error of whether the packet was just successfully submitted to the server at all. This is kind of like the one error. This corresponds exactly to this result. So if the packet status isn't okay, it's some kind of error, a single error. Although we may be submitting multiple operations at the same time, events at the same time. And again, right now we're doing very simple error handling, but this has to be better in the future. This needs to be more type correct. All right, so this is the status of this packet. And then here, this code all has to change. Because now we don't have one result, we have many results. So what we're going to have to do is first we're going to have to cast this result pointer to the correct type. And it's no longer a single TB account T. It's a vector of TB account T. We have the result pointer, and we also have result.len right here. Okay, so this assertion is no longer correct either. And this is going to be the byte length, I assume, if it's consistent with the data size we were looking at earlier. So what we're going to have is the result is a vec of TB account T. And to get that vec, we're going to say, and I just write this for kind of initial, to help me think, right? Eventually we don't need this type hint here. Vec from, we've done this before now, raw parts, and the pointer is result. Oh, okay, interesting. Actually, so our result is already a vector. It's a vector of bytes. And what we actually want is a vector of, interesting. Okay, we have a vector of bytes. We kind of want a vector of TB account T, but we don't want to reallocate, because all we're going to do here is we're going to kind of iterate over these accounts. So we have to iterate over these results and figure out which results, for our input events, what is the result? And not every input event is going to have a result, because the an empty result has a semantic meaning in this API to save wire space. So we're only going to get results for some events. Some events will have no results that take up any space. And so we need to kind of iterate over the results and then generate results for the consumer of this API, which means we might be like fabricating results out of thin air, saying like in our case, if we don't see a result, it means the account was not found. And we have to, instead of like making the caller figure out that an empty result means not found, we're going to do that for them, because that's fiddly and not fun. So we don't actually want a vec here. We want a slice, because we don't want to allocate just to do that iteration. So I'm going to say stood slice from raw parts. And there's going to be a bunch of ways to formulate this, but I'm going to create a slice first of the correct type, and then I'm going to iterate over that slice. And this is going to be result.as pointer, and you have to cast this because this is a byte pointer. I'm going to say as star const, because we don't need to mutate any of this. TBC TB account T. And the other raw part is result.len. So this is the byte length, and we need to create the account length. So we're going to divide this len by size of TBC account T, and this needs to divide evenly. And if our logic is right, it will divide evenly, but we kind of should make an assertion about this. So we probably want to say, instead of doing division here, we're going to say dot checked div, I think. And then we say expect div. So what this is saying is that we're going to do this division, and if there's some kind of modulus, then that's bogus. And we're expecting no modulus. Or a remainder if there's a remainder. Don't want that. I think this is the right way to write that, but I'm not entirely sure. So there's our result slice, and we can go type check that to make sure we did write that all correctly. And of course, no. This is TB account T. This is how Rust development goes. You write a little code, you type check it, and then the compiler usually tells you exactly what you did wrong. Often tells you exactly what you did wrong. Size of TB account T, expected value. Oh, I tried to pass in this type to the size of, but this is a type argument, not a value argument. And this is a call to unsafe function. So I have an unsafe up here, and I have an unsafe down here. I think I'll just put, I was considering whether I want to wrap all of this in unsafe or not, but there's enough safe stuff. I think this is going to be the only other unsafe thing I'm doing. So I'll say unsafe. And that type checks. So now we don't actually need this type hint here at all. That looks about right to me. Let's checkpoint our code. And there's, now we have to iterate over these things and correlate them back to our input. So let's go try to remember what our input even was. So our input events here, this is interesting. So our input events are a slice, and this is an async function. It's an async function. So the caller, by having a slice here and holding on to this reference, like we could make some annotations to say we're not holding this reference. And maybe that's what we should do. Maybe that's what we should do. If we hold this reference, then the caller needs to just hold on to this slice, or whatever the slice belongs to. They need to hold on to this for as long as the request takes. And again, they may be making lots of requests at once and holding on to lots of buffers. So really, we want to release this slice and not hold this reference. The syntax for that is, I don't know, but I believe there's some kind of recent Rust syntax that can say, like, I'm not, this closure, or this function, future, this future is not holding this reference. So again, like, we've already copied all this stuff in our design here. It's right here. So this future owns a buffer of these events. And in fact, we've even shadowed that slice, which is kind of problematic. And slice, because we need to, oh, that's actually good. So we've shadowed the slice. And then up here in the type signature, we're going to add some kind of annotation that says, yeah, we're not holding this reference. So we never need to reference this local again, or this argument again. And so again, the reason I was thinking about all that is because in order to correlate the results with the inputs, with the results with the requests, we need to go iterate through this again. So I'm probably going to make 2 iterators here and manually iterate over both of them because they're not going to iterate at the same rate. So we're going to say let event iter equals events.iter. Let events iter result. Interesting. Oops, sorry, chat. The underlying API of this field is called result, but we're kind of pulling multiple results out of that singular result. So I'm just thinking about the naming here, but I'll just call it result iter. I'm going to call this one results iter equals result.iter. And now we're going to have a loop. And Rust has just a unconditional loop, which I very much love. We'll figure out the conditions later. And then we'll say, let event next event equals events iter.next. Let next result equals events iter.next. And that is probably not exactly how we want to do it. Probably because the events we're going to iterate every time through the loop, but the results we're not going to iterate every time through the loop. So I'm going to make these mutable. Do I really want to do that? Yeah, because we're going to have to hold on to the next result. The next event, we don't have to. So we'll do it this way. This might make sense. Next result is that. Next event is this. And these are optionals, so they may or may not exist. And then here, after the next event, the termination condition for this loop is if there's no more events. So we can say if next event dot is none, we're done. And let's also assert, because there's not going to be more results than input events. So I'm going to say also next result is none. And then we break. We are done with this loop. And again, this could be formulated as a while loop, but one of the really cool things about loop, depending on your perspective, it's cool or not, is that you can kind of just like not worry about formulating it such that the thing your condition is available here at the head. So there's no like outer state here that is used in our head condition. The determination of whether we need to end the loop happens in here. Otherwise, this would have to be like mutable out here, in which case we have this mutable state that we have to think about. But, not in the small, not a big deal, right? But like anytime you can make something less stateful, pretty good. Downside here is that your break condition for this loop is, not at a single canonical spot. It's not right at the top of the loop. It's not right at the bottom loop. It's just wherever it kind of has to naturally be in the logic. But I love this. I hardly ever write while loops in Rust. I probably never write while loops in Rust, except for there's some cases. Anyway, so if there's no next event, we're done. and we are going to need some kind of accumulator. In the final API, we'll probably be iterating over these buffers and then returning an iterator of the results so that there's no intermediate allocation. And then the caller can just immediately collect those into an allocation if they want to. But for now, I don't know, it might even be easier to just write this as an iterator instead of a vec. Right now we're creating a vec. We'll do the vec for now. Let mute results accum equals this is a type vec. And for now we are returning, oh, this is our result, account lookup. Okay, that's what we're doing. Account lookup, okay, equals vec new. And this type hint here may not end up being necessary. We'll kind of, it might be able to be inferred from code down here, but I'm not sure yet. We'll test that later. And so again, we're iterating over the next events, the input events, and correlating them with possibly empty results. So here we have an event, and this next event, here we're going to have to unwrap it because we tested that it was none. So actually what we want to do here is probably create a switch for all the possible combinations, because these are both options, both event, and next result are, I'm going to put this at the top right here. It's like our goal. There's our stated goal for all this code down here. And even we can actually even put it all into another scope just to indicate like this stuff is all nothing, just leading to this vector. You could even make this an expression if you wanted to, but for now I'm not going to do that. I like this kind of fine-grained scoping. Just tells us like, tells their future reader that like this stuff is not going to be relevant in the future in this function. Okay, so probably instead of doing this, because if we do this is none case, then we still have the else case, right? And since we didn't like deconstruct that optional, we would have to say like next event equals next event dot unwrap, something like that. Though there's a bunch of there's a bunch of control flow constructs in Rust that deal with like wrapping and control flow simultaneously. And I'm always forgetting what they all do. There might be a way to do this check and like let next event equals sum next event equals next event else. That might be a thing. Next event else or something like that. In fact, I kind of want to go look up the Rust docs and see if there's a way to write exactly this. I feel like there is, and I have forgotten it because it's one of those like post 1.0 syntax sugar things that is useful, but there's just so much of them. Let's put a to do here. Let's just make sure this isn't real syntax that we've lucked into. It could be. Not mutable, events iter. Okay, iterators have to be mutable in Rust. Well, there you go, chat. I did luck into the correct syntax for unwrapping an optional. So let's bank that knowledge for the future. Of course, as you know, I'm always forgetting how to do everything. But this is an option type, and if it pattern matches the binding, it'll just unwrap here. If it doesn't pattern match, then you go down here. Well, cute. So the alternative here would be to put a switch statement, or sorry, this is Rust. Zig has switch, Rust has match. You say match next event, and then put the sum deconstructor like that, and the none case there. And this is also perfectly fine. But the whole reason for the syntax is so you don't have this double indentation level here. Because this is just, it's fine. It's just eight spaces instead of 4. But here you kind of follow this pattern while only doing no indentation. So here, all of your cases are going to be double indented, and here, all the positive cases, success cases, are going to have no indentation, which is very nice for readability, at the expense that your callers, your readers have to understand this syntax. Hey, I see you, chat. Oh my gosh, Bearded Superhero, thank you for coming in. I wonder how many minutes have I not been sharing my screen? I've been doing great stuff here, Bearded Superhero. I've been doing great stuff here. And one of my common problems that I have is that I forget to switch OBS scenes. Oh, I'm so bummed. How long have I been coding this? I've been coding this particular thing for a long time. Well, future viewers on YouTube, I apologize. I'll go over this, what we've done real quick again. So future viewers, 30 minutes ago or so, you should fast forward 30 minutes to this point. Sorry. So Bearded Superhero, you're asking whether these streams are saved anywhere. And right now they're not on YouTube like MatClad streams, but they're going to be. We'll create a playlist for this project. I'm doing a project to implement the Tiger Beetle Rust client. And the whole thing has been on stream on Twitch. And I'll upload the whole playlist to YouTube eventually, so that like future viewers should be able to see the whole creation project for the creation process for this Rust project from front to back. And I'm hoping that somebody will find it interesting or useful, because it does cover quite a number of interesting Rusty topics. Though, of course, there are 30-minute gaps where I am talking and not showing anything. So live and learn. And let me take a real quick sip, and I'll go back and explain all the stuff that I wasn't showing on screen. Yeah, I've only started streaming in the last 2 months, so still figuring out all the details, juggling all these windows and the AV production aspects, and while doing the performance aspects and the actual work of coding and thinking. Tough stuff, but good challenge. All right, so what we've been doing today, I'll show you 2 things, is we've been converting these requests. These are Tiger Beetle requests. So we're writing the client. This is the Rust interface to the Rust client, and it's going to submit requests to the server. And it does this by binding to a single TB client library written in Zig, but exposing a CFFI. All of the Tiger Beetle clients for different languages all bind to the Zig library as of now. And previously, I had written these submit methods, assuming that you submit one request at a time or one operation at a time in Tiger Beetle lingo. But actually, you are allowed to submit not any number, but some multiple number of events. So an events for a type of operation in a single submission. And the client underneath will kind of turn that, it might turn multiple submissions into a single network message, but by allowing the client to submit multiple events at a time of the same operation type, you can avoid a whole lot of extra work on the client side. Because as you can see in this method here, we have one allocation, 2 allocations, 3 allocations, 4 allocations. And this channel contains an internal allocation. This is all very inefficient. So if you had to do all these allocations for every single request, it's a lot of allocation. And if you can batch up requests on the client side, then you can kind of convert this 4 allocations, 5 allocations per request into 5 allocations per set of events. And so that's what we're doing. So where this previous method here submits one operation at a time or one event at a time, the new method that we're writing today submits a slice of some number of events at a time. Again, this is a lot of allocations. We've kind of done it the easy way so far. There are future ways to kind of reduce this huge number of allocations. There's another allocation down there, so many allocations. But this huge number of allocations, we can think of optimizing it later, but right now we're kind of doing the easy and obvious thing just to get the understanding of how it's all supposed to work. We'll make it correct first, and then we'll think about optimizing it as a next step. And that step is definitely going to be weeks away at this point. This project is going pretty slow since I've committed to doing it all on stream. Since I've committed to doing this whole project on stream, it means that I have to talk through and recontextualize and reiterate things I've done in the past and think and talk while I'm coding, which I'm enjoying the challenge of, but we're probably going about 1/3 of the rate I would normally code at. Plus, I also have to get up the motivation to do the streaming, not just motivate myself to hack, but also motivate myself to stream. So this project is probably going to span months, maybe. I don't think I will have even a preliminary PR done this year at the rate we're going. Okay, so again, we're creating this new submit account lookup to method, which will eventually replace the old method. And now we're in the process of handling the result of this submission. And again, we're submitting an array or a slice of multiple events at a time. And the results that the Tiger Beetle, both the underlying message protocol return and the TB client return, don't contain a result for every single input event. It gives a meaning to missing results, but we don't want to have to. So in order to understand the results you're receiving back from the server, you got to kind of look at both the input array and the result array, the request array and the result array, and figure out which results correspond to which inputs. But we don't want to force that complexity on the callers of our Rust API, so we're handling that right now. This is kind of the last step in getting this conversion done. So we're creating this accumulator. This is the vec that we're going to return to the user. And we're iterating simultaneously over the input events and the results and figuring out what the actual final result of every input event is. And so here's our next event. And this is our termination condition for this unconditional loop. And now we can say, we know there's a next event. So we know there's a next event. This is wrong. Something is wrong here. Event, next result is none. But here, next result is some. So here we said, if there's no next event, we're done, because there's not going to be more results than input events. And if we're done, there must not be any more results. And then if we get down here, the opposite is true. We're going to say next result that is some. So again, we also have to unwrap here. We have to say next result. We know there's something in this optional. We're going to say next result dot unwrap. And again, this is kind of an anti-pattern. Anytime you're unwrapping an option in Rust, you kind of think in the back of your mind, there must be some other construct that lets me handle both cases simultaneously instead of doing this unconditional unwrap. Like this is correct. This is never going to fail, but it feels wrong. It's a code smell. And I was just talking about the same code smell for this next event where before we added this very clever deconstructing binding and this else case here is a very fancy Rust control flow construct. I don't remember what it's called, but it's a deconstructing binding with a else case. We were unwrapping this next result as well, and we said, like, hey, future highway, bearded superhero, man, I really failed twice. I wonder if I'm getting tired. Yeah, future highway, I was supposed to be sharing my screen there. Give me 1 second to put my hands in my head. Oh. Good stream, y'all. Good stream. So, oh my gosh. Future highway, I was just responded to bearded superhero that, like, when I was writing all of this streaming is hard. Yeah, it's so hard. I'm learning. When I was writing all this code, I was not sharing my code. And I was just explaining that to bearded superhero. And then I said, well, okay, now I'll go back to the code and I'll explain all this code. And I, again, was not sharing my code. So all future viewers of the stream will just have to, imagine. I'm not going to go explain all this code a third time. My bad. I'm sorry. Okay, I got to forgive myself and move on, but that's super embarrassing. Anyway, double check. My code is on stream now. We created this really cute Rust construct to avoid unwrapping next event, but we can now see that, well, we still have to unwrap next result here, because in this case, next result is guaranteed to be sum. So to avoid this unwrap, really the thing we probably want to do, again, this is not a crime, right? This will work, and it will keep the straight line code. We could put another thing here just like this. Kind of the cleanest traditional way to handle this, where you have multiple options that could be some or none, is just to enumerate all the cases. Say match next event, next result, and then just enumerate all 4 possible cases here. But we've already the problem with this, again, of course, is that you have 2 levels of indent here. Every case is going to be indented and indented, where we much prefer this type of pattern where we just keep the exceptional cases get indented once, but they're small cases, and then we keep straight line code going down with no extra indentation. So what I think I'll do instead of this match is follow this pattern again. So we're going to say let sum next result equals next result else. And now we're going to get the next result. So for every next event, there actually may not be a next result. So if there's not a next result, again, there's not a result for every event. So if we reach like the end of the results, then we just kind of like know that all the remaining events have the result that is whatever semantically accurate for no result. In this case, when we have no result for account lookups, it means the account was not found. So if there are no more results, then we know that all the remaining events were not found. All the remaining lookups were not found. So now I'm again second guessing myself to use this, because these 2 cases are kind of equal. Like they're both valid cases. Like none of them is a termination case. Yeah, so good point. I'll switch these windows. Switch to, nope, that's not it. What is the Emacs command for switching buffer swap states? Right, so this buffer over here is kind of hidden behind my little window in the corner. So I want to code in here and just use this buffer for reference. Thanks, Future Highway. Yeah, so Future Highway, you're saying that you would not use that switch, and I agree. Like that switch matching a tuple is probably not the right thing to do here. But I'm thinking I might not want to do this pattern for next result either, because like I was saying, these two possible cases are both valid cases, so I don't really want to demote one to this else and leave one as the straight line case. I kind of want to make them both indented because they're both kind of like equally valid in some sense. So this is a surprising amount of thought going into how to, there's so many ways we could structure this code. And I'm going to say if let, so here we're going to do another destructuring control flow construct. If let sum next event equals next event, and then else here. So now no case has the straight line down here. So if there's no next event, let's do the case where there is a next event first. So now we have to correlate like whether that next event is, and this is probably going to have to be interesting. We also have to think about whether we're going to fully destructure this value or whether we just want to look at it as a reference. Because even though we're taking this next event, we might not use it. So even though we're looking at this next event, we might not use it. But if we do use it, we might want to copy it, and we might want to move it, not copy it. Though for this particular event, these events are only scalars, so move versus copying doesn't matter. But a consideration for the future is that, like, if we look at this and decide, if we look at this event and we decide we're not going to use it, then it's going to stick around as a value. Sorry, we look at this next result and decide we're not going to use it, it's going to stick around here as a value for the next iteration of the loop. So we can't move it in that case. We just got to leave it sitting there. So we probably actually want to do this. Though again, this is a scalar, so it's going to be copyable by default. So we could do either that or that. But semantically, like if you imagine, because we have multiple of these methods to implement, this could be a scalar in some cases. Sometimes it could be a big struct. It's probably not going to be like a compound struct that contains further allocations ever. But those structs won't be copyable by default, though they could be copyable. Kind of semantically for any type of object, we kind of just want to look at what's inside it right now and not copy it. So there's some question about what exactly we want to do here. For now, I'm going to do, there's also, okay, there's so many considerations here. If we take a reference to this next result, that means we can't write to next result. And at some point, if we do decide we're going to use next result, we are going to have to take the next iterator and overwrite next result. So that also suggests that at this point, we just want to move out of next result and make this stack slot semantically empty for a while, so we can overwrite it later. Complex stuff and a lot of ways to handle things, but let's stop yak shaving for now because the compiler will tell us eventually once we start making those kind of mistakes. So we got next result. Now we have to say, is this the result for the event? And in this case, we're going to say .next result. It's already a U128 that represents an account ID. So if next result is equal to next event, and the event is also just a U128 that represents an account ID. So this is And also, again, thinking ahead, duplicating this code for other types of events. I'm going to say are same, or result is for event. Let's name this so it's very clear. And in this case, it's going to be next result equals next event. But now that's very clear what this logic means. Result is for event. So if this result is for the event, then we're going to create our result for the user. I'm going to say results accumulator dot push something. And what we're pushing here is account lookup OK. And this is an enum that is either found or not found. And again, in this case, an empty result means not found. An empty result means not found. So a non-empty result means found. And actually, interesting. Okay, yeah, gotcha. The way our account lookup OK type is defined, we're going to return the account type with the result. So if we say found, here is the account that was found. And then the TB account T is, again, just a U128. I don't know if there's going to need to be a cast here or not. Let's see if we casted previously. Here's our old code again. And we did cast from the, we cast directly from the U8s though. And this, now at this point, we don't have U8s. We have TB account T's already, so there's no casting at all involved, no implicit or explicit coercion. So this is result next result. And if there is no result for this event, then that means it was not found. So we're going to say results accum.push account lookup OK not found. This account push could be factored out in front of this expression. That might make it clearer. Let's give it a look. So we can kind of write these two expressions in whatever order we want. Which is more readable. Bumping my mic. Yeah, I kind of like this one better. This is kind of showing like this is the thing that we're ultimately returning. Like this is our goal of doing all this, is creating this occurrence accumulator. Like if this was an iterator, we would also be saying like, this is not how you do it, but like yield that thing. So I like this. Push. Yeah. Let's do that. So now we've handled both cases when there is a result. Except, no. We have to do this backwards because there's more to do in the case that there is a result for this event. We got to advance the iterator. So this is just not going to work. We got to write it the old way. So if we're using this result, then we got to advance the iterator and say next result equals result iter. No. Again, this distinction between the plural results and the non-plural results is causing me confusion. This is not the result iter, it's the results iter. I'm going to go back and call this the non-plural everywhere. thought it would be clearer if I made the some cases plural, some cases not, because this is not a result, this is many results. But you could also say this is an accumulator of result. It also makes sense. And result iter dot next. So now we've set the next result. Not found here, and here it's going to be the same. So this is the case where there is no next result at all, and that means there will never be another next result. We're just gonna push that. And I think that's the entire logic for correlating the results to the requests. And again, at the moment it's a vector, but future probably it'll be an iterator. But here we can just say return OK result accum. And we don't need a return statement at all. Okay, so we just spent a long time writing this method without ever type checking it. No, we did. We type checked all this stuff up here. So it's not going to be too bad, but now it's going to be quite a while of just fixing errors, but maybe not. Only 2 errors. That's kind of miraculous. Okay, this is supposed to be a TB account type, and it's got a reference to a U128. Where is this next result here? Why is this this is a reference. So this next result, interesting. Okay. Is going to run into borrowing issues again, because this is actually a result of, this is an iterator over references. This is an iterator over references. So this next result is going to be an option of a reference, which is holding a reference into this, not this iterator, but the result vector way up here, the result slice. So even if we resolve these errors here, probably we're going to hit some borrow check errors. Let's go ahead and just show that. So here this is, we're trying to create push a TB account T here, but we actually have a reference to a TB account T. I think TB account T is just a type def for a 128-bit. So to fix this in the obvious way, we're going to say dereference that. But I suspect this is not going to work. And then down here, this next result, expected, oh, I shadowed next result here, so I can't assign to it here. But, you know, kind of no worries, because the strong typing is going to catch that like 99% of the time. Shadowing in Rust is good. But that means I do have to say, give this a different name. I'm going to do my kind of lazy way of differentiating 2 values that are similar with the underscore. I think almost nobody likes that as a practice but me. Like if I was writing like ML, maybe, I think ML allows it. Or just put like a tick. Next result prime. That's what this underscore means. Next result prime. Pretty ugly though. Pretty ugly. There's a lot of kind of semantic confusion here, because there's not very distinct seeing this next result prime. But let's at least get it to compile. Yeah, I'm kind of screwing up all over because of that naming. And let's see, that should resolve both these errors. And it, oh, I guess I was wrong. I thought TB account T was a type def for U128, but it doesn't seem like it is. Huh. Okay, let's investigate that. Actually, let's fix, okay. I might just have some type declaration wrong up here. Fence iter, result iter, result type, U128. This is the payload type is U128. Let's go look real quick at what a TB account T is in the C header. Because I think both the input and output of this are a... Oh, I'm totally wrong. I'm totally wrong. TB account T is actually, yeah, U128 is copy. TB account T is not a type def. So U128s are the IDs of account T. But again, I've made this mistake in previous streams. We're not just looking up the ID, we're looking up the full account record of the ID. So TB account T is absolutely not a U128. So account lookup OK. Somewhere we cast these results to TB account T. So the result is already a slice of TB account T. And basically what did I do wrong here? Where is it expecting a U128? Account lookup found, next result. Type of next result comes from result iter. I'm just looking whether I put an incorrect type annotation somewhere, but this result is message.result, and message, this is probably the wrong, no, that's right. This result is actually a vector of bytes. It's just the buffer of the result. Here it is. Nope, that's right. Where's this U128 type coming from? So this result is saying I have a slice of TB account T. Why is this expecting? Well, that's a TB account T. This next result is a U128. This is quite a mystery. Next result is next result. Next result is an iteration. Ah ha ha ha. Gosh. Just a typo here. So my next result should be the next item out of the results iterator. But I wrote this wrong. Oh, that's a lot better. Result is for event. Result is for event. This is no longer correct because next result is not an ID. It's a struct that one of the fields is going to be an ID. So now let's go look at what the definition of that struct is. And that is in tbclient.h, tb account T, right here, ID. There's a field ID. And again, there's a mismatch between the pointeriness of this type and the value type. So this next event, this is currently a reference. We're going to dereference it to get the value out of it. And now I'm expecting a borrowing error here, but we'll see. Maybe sometimes the bar checker gets improvements and sometimes it lets more and more code pass, but I'm expecting this to be borrowed. I'm expecting this to fail because this is borrowed, basically. I'm wrong. Let's think about that a little more. So, that's why. Okay. Actually, let's go talk that through again. So this results iter is an iterator over references to the elements of result. So that means this iterator is holding a reference to that result vector. This next result is an option of references to the TB account T's in that result vector. So basically, Basically, each element here is holding a lock on the iterator. The iterator is holding a lock on the result vector up here. So you would expect, if we're still holding references and down here, we are destructuring this element. But here we're overriding that element. If we were holding a reference to that element, then we couldn't overwrite this because that element is holding a reference, is holding a reference, is holding a reference. All these values, all these locals are locked. But because we actually destructured this, we moved this option into this destructure here. Now the reference is here. And this is still basically locking all those other values. But down here, here we assign to next result. Next result is not locked anymore because it was destructured into this reference. And because these are all immutable references, we can still pull another immutable reference out of the original vector through the iterator and assign it to this slot, which is actually unassigned for this block here. Like after we move next result into this destructuring assignment, that next result slot is inaccessible through here, through control flow analysis. And so then we can reassign it here. That's more or less why all that works out with borrowing. Adjective Allison. Tiger Beetle is written entirely in Zig. What I'm working on is the Rust client for Tiger Beetle. So this is Rust code for talking to the Tiger Beetle server. And it's not written entirely in Rust. This Rust client is just bindings to a library called TB client, which itself is written in Zig. Eventually, we may write a pure Rust Tiger Beetle client because that will in some ways be more convenient for Rust consumers. But yeah, Tiger Beetle is 100% in Zig and will always be 100% in Zig. Yeah, so thanks for appreciating my explanation of that borrowing situation. I'm sure someone with more expertise would have explained it a little more accurately, but I think that my explanation there kind of gets the gist across of what happens with all those little reference locks as the code progresses. It's very hard sometimes to understand what's going on with borrowing in Rust, and this is like an easy case. Sometimes you just have to be like, it's doing what it's doing. Oh yeah, you were here looking for a Zig and you got Rust. That's a bummer. This channel is often about Zig because Matt Clad comes here and streams about Zig on Thursdays. But I guess it's kind of ironic that at the moment the Tiger Beetle Twitch channel is mostly about Rust because I'm doing this Rust project pretty frequently on here. I saw Future Highway. You were talking about the copy of TB account T. There's a deref in here still. Is that still the case? Am I still missing something with TBT account being copy? And like, you're right. If we look at this TB account T, all this is copyable. So this should be copyable in Rust, but keep in mind that that might not be the case because this is the C definition and our Rust definition is elsewhere. tbclient.rs. Do we have that? tbclient.t. And it's true that structs in Rust, if they can be copied, they will be kind of automatically copied. So you're probably right about this, but I just want to go look at it. Wait, TB account T. Struct TB account T. So TB account T is here. Oh yeah, and you can see that. Oh, that's not true actually. Wait, is it true? I think you have to derive copy. And if you derive copy, you have to derive clone. Yeah, so structs are not automatically copy in Rust, even if they could be. But you can see this file here is generated by BindGen automatically from the C definitions. And BindGen just gives you all these conveniences by default. So this is copy. So you're saying in the enum found, this is copy. Yeah, it's copy, but this is a reference. I don't think we can remove this dereference here. Let's see, this is an option of a reference to TB account T. So this is a reference to TB account T. And so this is dereferencing it in order to make it copied. Let's try to remove it. Maybe you're right. Yeah, so we're just trying to put a reference into found here. Yeah, so this needs to dereference this. And I was thinking we would do all this stuff by value here, like make these a into-iter. Into-iter will kind of consume the original result. I thought the borrowing would force us to make this into-iter, but it actually doesn't. It all works out. Yeah, copying is not automatic. Okay, we've written all the code I intended to write here. Now the thing is, it all type checks, and we need to actually run it and see if it works. I'm skeptical. Just checkpoint our code there. So this entire stream, which has been running for a while. Let me see real quick here. 3 hours. So that's interesting. I've got this I'm starting to run out of steam, but I got this standing desk here. So I have to stand through my entire stream, and I've been 3 hours is about the max I've been able to go. In the future, I might make it so I can sit down for the streams if I need to, but I'm glad. So I've been trying to decide like whether I'm going to, I want to set up like a schedule. So maybe like once a week, promise that I'll stream at a specific time. And I haven't really been able to figure out like whether I like streaming best or whether I'm more motivated to stream at night or in the afternoon or in the morning. And for me, this is an afternoon stream and it's gone pretty well. I've had energy. My brain has not been super foggy. And I've been able to stand for 3 hours. So I might schedule something like this time on a Wednesday once a week. All right, let's go back. And the thing we're after now is we're going to try to test this code. And so here's our test code. Previously we were, and again, this is not a unit test. This is just kind of like an ad hoc test for development. We're creating an account, and then we have to look up an account. But now we're not going to look up a single account. We're going to look up multiple accounts. So we have account ID here. And there's account lookup 2. And we're no longer using this intermediate struct here at all because it's just noise. And this is now some kind of slice. And let's put some other valid accounts. You know, our test database we've been using for haha, Ejective Allison, you got me. Oh, chat, you've been helping out so much. Always screwing up with my screen sharing. Thank you so much. Thank you so much. I'm so bad at this. Oh my gosh. Yeah, that's the third time this stream I forgot to switch scenes. All right, so we're going to look up multiple accounts at a time now. Oh man, I'm learning. We're gonna look at multiple accounts at a time, and we're just gonna debug print those, and we'll expect this database. We've been using it for a few weeks now, so it's got some accounts in it already. So we know this is the account we're about to create, and then we can put some. This account we created previously, and then we'll do one here that we definitely haven't created yet, and then another at the end that we definitely haven't created yet. Because remember, there's at least 3 cases here in the correlation code between the requests and responses, and I kind of want to make sure they're all covered here. Okay, So 2 of these should be successful lookups and 3 of them should not be. And this account here, this submit create account is going to fail because this account exists, but that's fine. We're not testing that. We already know that works. We're just testing this. Let's run that. And okay, it found ID 12. That's great. This looks wrong though. We have 1, 2, 3, 4, 5, 6 results. And we had 1, 2, 3, 4, 5 inputs. We had 5 requests and 6 results. Something's not right here. 1, 2, 3, 4, 5. That is the case. And one of these we expected to be successful. 0, yeah, 0 might not actually be successful. Let's try 1. I don't think I ever created a 0 account. Okay, there we go. There we go. In this result, we have 12 and 1. And then there's 2 not founds here. Something is wrong. We have failed to progress an iterator or something. So here we press next event. Here we do next result. Here we don't do the next result. Timestamp. I think these are logical timestamps, but I'm not sure. I don't actually know Future Highway. Yeah, these are very big numbers. I don't know if these are physical or logical timestamps. The database, the server itself has logical timestamps that might not be related at all to physical time. But what exactly this timestamp represents, I do not know. Could be nanoseconds. Could be nanoseconds. This doesn't really look like a logical timestamp either because these numbers are so different. I would expect logical timestamps to not be progressing that fast. So you might be right. It might be nanoseconds. Okay, so again, something's wrong here because it says not found here. So this also suggests that like we should make an assertion here. Assert EQ. What are our 2 vectors called? Events and result. Events.len and result.len should be the same size. And we can go over here to cargo run and incorrect. Oh, that's not right either. Not results.len, but the result accumulator that we have fabricated should have the same size. And here it's 7. Interesting. I counted 6 before, right? Oh, no. It was 6 before the successful one was here. There's definitely some logical bug in our iteration there. So now this is 1, 2, 3, 4, 5, 6, 7. There's an extra one here and an extra not found here. There's 2 extra not founds. It seems like every time we create a successful found result, we also create, for some reason, a not found result. So that's a clue. And the only time we get a found result is here. So if it's found, we're consuming both the event and the result. This seems like maybe it's not consuming the event here, but we do call next event every time through the loop. This looks wrong. Is this wrong? No, this is breaking. This is just exiting the loop. There's no continues in this loop at all. So every time through this loop should be consuming one of the input events. So it shouldn't be possible for this loop to execute more times than events. Let's go ahead and enter, let's just create a iterator or a iteration variable here. Just print something every time through this loop. We don't even need a variable, just print line loop. And there should be for our inputs 1, 2, 3, 4, 5 times through this loop. This loop should always iterate exactly the amount of times through this event. And that invariant suggests that we could iterate over our range here, but it seems like pretty simple logic. 2, 3, 4, 5, 6, 1, 1, 2, 3, 4, 5, 6. Well, that's weird. So we iterate this 6 times for 5 inputs. 6 times for, we have 5 inputs that we iterate over 6 times to create 7 results. Oh, I'm doing something really dumb here. How can this, let's go ahead and just print this events. Events is here from raw parts. Events down here. Events.iter.copy.collect. So that's just cloning the input or collecting the input into a vector. This vector assert, I mean, this can't be, this couldn't have grown, right? Not there. Down here, when we're handling the results. Events.iter. Oh, interesting. So before chat, I was saying that we had shadowed these events with a vector here, but this is inside another block of code, and we never create this vec anywhere else. What is going on here? Events. This is the data. So we put all these events into a vector. We forget that vector and hand the ownership off to the TB client. But where do we reclaim ownership of that event vector? Result. Packet. Is it inside this message? Maybe I already have it inside this message. So inside of here, we do take the events back and we put them inside completion message 2. But it looks to me like we never use those again. So I'm going to say down here, because remember, from long ago at this point, we don't want to hold on to this reference because this returns a future. And after this future returns, we want the caller to be able to just release whatever buffer this is. It'll be more convenient for them. So we don't want to hold on to this to the future. And down here, it appears that actually we are iterating not over the allocation we made to hold all those events, but we're iterating directly over that slice of events from the argument. So I screwed up there. Let's say let events equals message.events. So here we're shadowing that argument so we can release the borrow with our vector copy of those events. And now we're iterating over those events. And I want to print here the length of this vector to make sure we haven't accidentally added a 6th element to it. Because again, down here we are events iter next. No, this looks okay. Here we're executing this loop 6 times somehow, which just doesn't seem possible from what I'm reading so far. All right, Odd Juice TVs thinks he's got a lead on this. So pushing a not found before the else statement. Push not found. What is going on here? What, oh my gosh, I've written a crazy error here. You're right. You're totally right. That is a bizarre syntax error. So this is an if-else statement, but I didn't write else here. I don't think I've ever made that error before. That is weird. I've never even seen that error in Rust before, but like totally valid syntax to just do this, because this is an if statement without a corresponding else branch. And this is just an open brace. Like this is actually this, right? But it parses just fine written this way. I'm kind of mind blown here. I've never seen that error before. Good catch. Good catch. That's probably the whole thing. That is probably the whole thing. All right, so now we have 1, 2, 3, 4, 5 results. Found 12, not found 0, found 1, not found those other numbers. Oh, it's all working now. Great catch. That's awesome. I was kind of worried because it's like such an obvious, like clearly the logic bug here must have been obvious, right? Like this code is pretty simple. Okay, so we've achieved our objective for this stream at this point. We rewrote the old account lookup method that only takes one account into an account lookup method that takes multiple accounts. And if this does have too big of a slice here, the underlying TB client bindings, the underlying Zig library will return some kind of result that we probably need to handle better. So like right now, when we get an error from the underlying TB client library, we're just kind of passing it right back up. We were just laughing at it. Odd use TB. Good stuff, bro. Or sis, whatever. Good stuff, y'all. So this error case will probably have to be expanded in the future. Because right now we're just saying, whatever the underlying error is, splat it into a string and pass it back up to the caller. But really, there's probably going to be cases here like that we have to translate in some way to something that the caller can make better use of. But that's for another day. I'm not going to worry about that now. But we can go ahead, I think, and just delete this old method because it was incorrect, but now we've corrected it. And this other method here for this submit create account, next stream we'll convert this in the exact same way. I don't think I'm going to have the energy to do it now. But we have to convert this to accept multiple events. Let's make sure this all builds again after I remove that method. Yep. And again, just recapping, all these types that we've defined for the API so far, they're all kind of like re-exposing the underlying C bindings types, which you also have to change at some point because that's not really suitable for a Rust API. And before we go, I think, before I was talking about we need to release this slice from the future that we're returning. This is an async function, so this is not actually a result, this is a future of result. And by default, I believe this future will hold this reference. So any lifetimes that show up in the input will probably be automatically put into this automatically defined future type. And again, we don't want to do that. And that's kind of why we ensured that in that loop, that iteration at the end, we don't use this slice. We use the heapified copy that we previously made that is owned by the future. Because we want the caller to be able to reuse this buffer immediately after submission. And I know in Rust, there have been some recent ways to put annotations here about lifetimes, right? This is one of them, I believe. This is saying we're going to hold a reference to something, some lifetime. I don't remember what it means. Handling lifetimes with futures in Rust is pretty mind-bending, and it's kind of beyond my abilities. I just oftentimes when I'm dealing with futures that hold references, I just kind of, type and figure it out eventually. And I think there's a new syntax that'll just like say, no, we don't hold this reference for sure. And we can kind of I want to try to figure that out before I end today. I've got energy, so I want to keep going a little bit. And we can kind of try to test the hypothesis that, yeah, our future is holding this event by writing some code. So I want to say, let buff equals, what is that? There's my message that I put in Slack before I started streaming. Interesting. I should make sure I clear my copy paste buffers before I stream. Another thing to note, another thing to keep in mind. There, this is our slice. I'm going to say vec from, hopefully this just works. And then I want to say res future equals that. Equals buff. And then I want to say let res equals res future dot await. And between these two things, I actually want to free that buff. So I'm going to say, how do you do this? Drop buff. And I'm not entirely sure this is semantically enough to make sure the compiler forgets about this buff variable. But let's just see if that generates an error or not. Oh, there's an error. Borrow buff occurred. Oh, this looks like a borrowing error. So we're borrowing, here's the owned buff. We're borrowing it into this submit method. We're dropping it here. So we're moving the buff into the drop function. And then here, we are still using that borrow inside this future. Yeah. And this help says, oh, you could clone that buff if the performance cost is acceptable. So that's all pretty nice. But that's not how I actually want to solve this problem. Remember, I want to type annotate this future to see if we can tell it like this future does not contain the events reference. I think we're gonna have to switch scenes over to the browser for a while. So everybody try to keep me honest when I switch back over to the code. I don't want to have a fourth incident on this stream. And there's some kind of syntax in Rust, definitely in the release notes somewhere. I'm trying to remember the easiest place to figure out what the syntax is. I think it's a pretty compact syntax. We might just add ChatGPT. Maybe ChatGPT understands it. In Rust, I have an async function returning a future. The one method to this function is a reference. And what did I call it? Give it some concrete code to work with. I'll just give it our whole method signature. I'm always forgetting how to copy paste from this particular terminal. One of the functions is reference. I want to declare the method such that the returned future does not contain the lifetime of this reference. Here's my signature. How do I annotate the return value to not capture the lifetime of events? All right, that's a pretty thorough explanation. Hopefully it understands. We could say static, but that's not good because we have to capture self. Actually, do we have to capture self? We may not even have to capture self. In that case, it's super trivial. Well, this is not what I expected at all. Maybe it doesn't understand the thing that goes here. Or maybe I'm just forgetting wrong and it doesn't really exist. Async move. So here, that makes sense. So this async move block will ensure that it doesn't capture anything. Like all the captures will be moves. But I'm actually not sure that Rust will automatically analyze that and say, annotate this type with .tick static. I'm very curious. Anyway, though, that's not the thing I'm looking for. Let's keep looking for a second just to see if we can find it. I don't know how to find it, though. ChatGPT can't give me a hint. Maybe Rust release notes. This is going to be, the stream is going to get boring here for a while. Oh, it's all on the same page, so that helps. Async fun. Stabilize async function, return position infiltrates. I know I like read this on like a summary blog somewhere recently, but oh, I know where I read it. I read it in the end of year Rust survey, which I assume I can't go back and take again. Async function return, no, that's not it. Must use, that doesn't look like it. That's just a bug. You can now create async functions and blocks with async function, async move, and async. Okay, that doesn't. This is very old. All right, async function was not suitable. Tick. It's something like no capture, something like that. Let's just search for that. Doesn't look like that's going to catch it either. Let's go back to the top and search. Doesn't seem like that's going to catch it. We need a Rust expert in chat. I know I'm supposed to be the Rust expert, but kind of a phony. Yeah, this is very old code. Let's test ChatGPT with a little bit. Maybe it'll figure this out. There's a new Rust syntax for annotating lifetimes of async fun return values to explicitly say this lifetime is not captured. What is it? Yeah, it doesn't know. That could be it. No, that's not it. That's totally not it. This is ChatGPT is confused. Maybe I'll just have to punt on that for another day. Or maybe we can type a bad syntax in. Oh, Adjective Allison's about to figure it out for me. Man, having people in chat that know what they're doing is very helpful. I was thinking like also I could figure this out by typing like no cap. Maybe it'll figure out what that is. Like events. I could be like totally wrong and this might not even exist. Adjective Allison is good at prompting. All right, I'm going to copy your text here if I can copy that link, and we'll go over to our browser. Oh, Chad, I was again typing in the terminal without telling you. Okay. Simple fun. Here's capture plus A, saying it is capturing A. None of these things are the thing I'm thinking of. Async fun. Let's look at their async functions. Are any of these async functions? No. Don't think this is it. Adjective Allison. Good effort, though. Man, neither Claude or ChatGPT could figure out what this thing is. Let's go back to our approach of just prodding the Rust compiler for a second. No cap E. Nope. It's just totally confused by what I wrote. It's also possible that my compiler is old, but I don't think it is. Oh, so definitely I have to declare some lifetimes here if I'm going to use them. So I've given this event's lifetime a name, and then I've said this function type's lifetime E. And then I've tried to say like, yeah, don't capture this thing in this closure, but it doesn't seem to be the right thing. All right, so Allison, adjective Allison, this async fun is like super syntax sugar for a function that returns a future. So this return type here is not the return type. This return type is actually future of item equals this. It's this. And the syntax sugar here just does magic with captures. It's like, it's too complicated to write out all the lifetime bounds that live inside that future. We're just going to figure it out for you. But what happens is that it's easy to over capture lifetimes. Like the type of that future actually says, like, oh, this contains tick self plus tick E. It's kind of pessimistic, and even if you don't capture these things, it'll return a future that thinks it's captured them. Yeah, but there's some kind of syntax, I believe, that was introduced in the last year that lets you annotate and say, like, oftentimes in Rust, you can say, like, okay, this captures this lifetime. Like, this result type contains this lifetime. Oftentimes it's inferred, sometimes you have to say explicitly. But I believe there was a syntax that says, like, not this lifetime. But I don't remember what the syntax is. If we can't figure it out, though, we're probably just going to go back and try the approach it used of putting all this stuff in an async move block, because then maybe it'll infer the correct lifetime captures that we're looking for. Expected one of, here's things that it expects. I said not E. Oh, I'm missing a closing bracket. Type aliases cannot be used as traits. I don't know exactly why it's saying that. Okay, so there's our borrowing error. Plus tick E as traits. Oh, okay. So this syntax for saying what you're capturing is only valid for trait objects, and that's what it's saying. It thinks I was trying to create a trait object. So I clearly just have no idea, and even if this feature I'm thinking of exists, I'm not close to getting the syntax right. But let's do one more thing and try to say the thing that we're returning here is going to be moved. Impl future. So that tick. Wow, what is that syntax? Precise capturing use syntax. Use is it. Use is what I was thinking of, but the name use tells me that maybe it's not actually what I was thinking of, or what I actually wanted. Adjective Allison, you're posting a syntax in there that I don't even recognize. Oh no, that makes sense. That makes sense. That tick A capture, the tick A lifetime bounds in the future. So I'll post all this over to my buffer so I can talk about it a little. All right. A lot of people in chat trying to help me out with my confusion. I appreciate that greatly. Just formatting this. I hope you don't mind, chat, that I'm putting your stuff in this buffer. I don't think it's too private. So this here is syntax for specifying exactly what you want as your bounds of a future. This could work. So here this is saying this is capturing A. And so we might be able to put like, give the self parameter in our method. This is and tick s self, right? Might be able to say that and put tick self here, which says like it's not capturing A. Or we might be able to put this. I don't know what this does. You can definitely put this, but then you can't capture self. This is kind of embarrassing that I don't remember how to do all this stuff, but I don't work with async functions in Rust very much, and it's all very complex from a type theory perspective, very complex. If we put tick static here, then we're not allowed to capture self, which may be okay, but I kind of also don't want to limit us in that way right now. What I was thinking was something like no capture here for tick A. But that doesn't exist because it looks like Aju's TV, you have found the thing that I was actually interested in, and I was just totally misremembering what it is. This capturing use syntax is definitely what I was recalling, but it sounds like not what I was looking for. But let's go read the blog post together, or at least scan it. What is that? That's not a narrative. Rust now supports use syntax within infiltrate bounds. Okay, this is not specific to async fun, because like this infiltrate size is a trait, future is a trait. So async fun is sugar for a return type of impl future. And presumably the syntax will work directly on an async fun, but I don't know. Return position infiltrate types. It may not actually. We might have to explicitly say it's an impl of future, which could be fine. We may be able to say like fun, async fun, impl future. That might be possible. But yeah, you can see here that it's captures a lifetime that does not appear in the bounds. The new use, we can say capture underscore lifetime. I think I can't remember the semantics of tick underscore anymore. That's tough. Captures, yeah, okay. The captures trick. This is exactly what I was thinking of. The outlives trick. Huh, okay. Let's look at this, the problem that this use syntax is solving really quick. So here, we're returning some impl that captures this lifetime here, but we weren't explicitly saying so. And you could previously name this lifetime and capture it, or use this wildcard lifetime, which presumably captures, whatever if there's one lifetime, maybe that allows it to just capture it without naming it, possibly. But here, why couldn't you just write plus? Oh, right. The text down here was saying that you could just write the lifetime here, but in some cases that are definitely way beyond my ability to ever comprehend, this is not exactly correct in all cases. So I believe somebody in chat, brought up this syntax before, or maybe even ChatGPT suggested this, to say like, yeah, we're capturing this. But none of this is directly related to impl fun or to async fun. So let's go toy around a little more. This use syntax, it seems like it's kind of a red herring. It probably isn't what I'm looking for. Let's go toy around with this function a little more, and maybe we can get it to work. So the next, I appreciate all the help, chat. Thank you very much. The next thing is let's put an async block here, async move. And so this also creates a future, but an inline future. We could assign this to like anything. It's just creating a future. And the move keyword here says, kind of like with a closure, everything this future captures is going to be moved into the closure, or the future in this case. And here we should be able to say dot await, because remember our type signature up here says we're not returning a future, we're returning a result. So basically the entire body of this function is going to be wrapped in a future. So down here, we don't just return a future directly, we await that future. And we return the value inside of this little local future. And I think this is what ChatGPT was initially suggesting. So presumably, if this works, then the control flow analysis in Rust will say like, okay, this future that we're waiting for in order to return the result definitely is not capturing anything, because it's essentially a move closure, a move future. And then maybe it'll automatically just say, okay, this doesn't actually capture any lifetimes. So let's just try that and see if it works. And if it doesn't work, I'm going to go give up. Think about it some other time. It doesn't work. It doesn't work. Let's do one more thing. And this is a result. So this is not the future. This is a result, a future of something. It's an impl future. So it's a implementation of the future trait that doesn't have a concrete name. It's not nameable, this result type. Plus tick static. Let's see if this works, because tick static will say this future definitely doesn't capture anything. But I think if we write impl future here, we do have to not make this an async function. And then we can kind of just remove that await. So now we're returning a future. The big problem with doing this kind of pattern is a trade-off here. It's basically a documentation trade-off. There's also some trade-offs in how you can handle the types. Like the documentation is going to look like this. It's not going to be say it's an async function. And having that async function in the docs is a very clear indicator of how something should be used. But also this type is not nameable in any way. But that's also true of automatically generated future. This type also hard to read. Like this future stuff around it is just kind of noise. We don't care the fact that it's a future generally, just that it's something that we can await someday. But let's see if this type checks just for fun. And this is not just future, it's stood future, future. I'm really getting into the weeds here, y'all. Result in not a future. Why is this not a future? This is a future. This is a future. Result anyhow error is not a future. Oh, duh. This is not the correct syntax for defining a future. This result type here is an associated type. So you say item equals that. And all that error looks the same. Okay, I call it await inside here. Can't do that there. You got to put that await inside this big async move block. This is getting really too in the weeds for my taste right now. I'm already been standing for a very long time. We're going to wrap it up. And let's see, can I just check out all these bad changes I made? No, but we can check out. I'll do some research into this problem because the basic problem is we don't want to capture that slice inside of this future. And I'll go do a little research into how to do that correctly. It's been a long time. And again, like I say, when I'm dealing with async programming in Rust, I often just mash the keyboard until it compiles. Okay, so today we have made a lot of progress. We figured out how to submit a full buffer of events of a single type of Tiger Beetle operation to the server, and then parse out the results correctly and hand them back up to the client. We attempted to figure out how to not capture this particular buffer in the future that we're generating, but we totally failed. Also, I failed to switch to the terminal in OBS 4 times. So if you made it through the stream, it was an adventure, and a lot of what I was talking about was not demonstrated visually. Sorry. I'm going to learn from that, and next time I'll do better. Next time we're probably going to do some API cleanup. So we kind of know the pattern now that we want to use in order to submit requests. But again, like I showed you before, the types we're presenting in the Rust API expose a lot of the underlying C types, and the Rust API can't do that. So it's probably now time to think a little bit harder about what the Rust types should look like, and we'll kind of hide all the C API details from the user. And then we'll have a really good template for implementing the rest of the Tiger Beetle operations. And then we'll go on to implement all the Tiger Beetle operations, and we'll kind of be home free at that point. I can't really envision the road ahead beyond that, but that work should last several streams because it's taking a while to implement each single operation. But again, we have a blueprint now, so they should go much faster from this point. Okay, chat, and anybody watching this in future on the YouTube, I really appreciate it. I'm doing these streams irregularly, but soon I will probably schedule at least once a week a fixed time, maybe Wednesdays at some point, and that'll be on the Twitch schedule. And pretty soon I'm also going to figure out how to upload all the recorded videos that we've already done to Tiger Beetle's YouTube channel. So this series should present ultimately a pretty coherent, demonstration of how to do a complete project in Rust over time someday. It's been fun, everybody. I really appreciate everybody helping me out in chat and taking the time to be here and, participate in this. I really appreciate it. Thank you very much. See you all next time.